morning, or afternoon, or evening, whatever it is, wherever you are. Back with Christos, and we have a special guest today. And but before we jump into what Nills is going to work on, what's going on, Christos?
Oh man, you got your blue screen back there. That's awesome. Now I'm envious.
Well,
I need to hide. I need to hide all this at the back.
I have to say it's sort of taken over my office. So there's this giant.
Nobody has to know.
There's this giant. I don't even know. There are two tripods that hold up both ends of it. So I'm thinking I need to figure out a way to pull it down from the ceiling, so that the rest of my when we're not doing this, I can still have most of my office back. But whatever. It is what it is. I tried to find a proper green shirt for this morning, but I couldn't. Just be a floating head, But I had one a long time ago.
One of these days.
It fit a long time ago. It doesn't fit now. So.
Damn it! I forgot I was going to go with pink today because I remember Todd said, pink will probably look good on me. So for Thursday, I'm definitely putting some pink on.
Well, I mean, do you own any non-muscle shirts?
They're called tight fitting, my friend.
I mean, we spent like 6 hours.
It's just cleverly positioned fat. I would not call it muscles. It's just fat in the right areas. That's what you need.
I mean, we spend 6 hours a day on videos. So. Oh, okay.
I need to find some loose fitting ones. Now I feel a little bit targeted, but it's fine. It's fine. I'll take it.
All right, cool. Well,
hey, Nills.
Yeah, we got a guest today.
Right. Good morning, good afternoon, good evening, everybody.
So, Christos, you wanna introduce Nills?
Yes, although I think he can do a better job at introducing himself. But I synced with Nills on Twitter the other day. So he was talking about Terraform. I think he was doing some great stuff. And I was like, hey, are you doing anything with Terraform and Azure AD? It's like, yeah, sure. It's like, yeah, you should come to our show. So this is the start of our conversation. This is the first time I'm working with Nills. But apparently, Nills used to work in the Belgium subsidiary at Microsoft. And we were very close since I was in the UK. And in fact, I jumped to Belgium quite a few times for conferences and customers. So I'm surprised that we haven't really crossed paths. But apparently, we had to come to the US for us to connect. So Nills, tell us a little bit about you.
Yeah, and even in the US, we're further away than we were in Europe. Bay Area. My area of focus is everything related to, I like to call it cloud automation. So that ranges from doing infrastructure as code with either ARM templates, Terraform, going into a lot of work with Kubernetes that I'm doing. I even wrote a book a couple of months ago on hands-on Kubernetes on Azure, which was a really fun experience. And this will be my first time live coding on Twitch, so I'm a little bit nervous for this experience.
Oh, don't be nervous. Take it back a little bit. Did you say you wrote a book a couple of months ago and it was a fun experience? Did you put fun in quotes or did you actually mean fun?
I think fun in quotes because the writing experience itself took a hell of a lot of time, even more time than I had anticipated.
Yes.
But I think even though it took a lot of time, what was fun about the experience was just when you're writing a book, you don't know who's on the other side. So you really need to take it down to basics again for yourself. And you always forget all the assumptions that you take yourself about how something works and about some of the words that you use. And it was just very interesting for me to try to take things down to zero. Right. And I even learned a couple of things myself by going back to zero.
Yeah, it's a great experience. And funny thing is that streaming is more or less the same thing, especially if you're doing live coding and stuff. You have to assume that the person on the other end does not really know much about what you're talking about. And as I was saying before we started the show, something that would usually take you half an hour to complete, it takes an hour and a half now or 2 hours because you try to explain the thinking behind it or the steps that you need to take at each level. Sometimes you actually point to docs or you have to. And this is what we'll be doing today. And it's going to be honestly, it's gonna be fun without the quotes this time. Because we touch a lot on developer stuff these days, but we don't do much with DevOps, or we haven't done much with DevOps yet. And it's great to have somebody that does it day in, day out to help us do that.
Yeah, I think I touch DevOps daily in my work with customers. Most of it is a combination of Azure DevOps and Jenkins. I know Azure DevOps pretty well myself. A lot of customers use Jenkins, and they both do the same thing. They're just different platforms with some different capabilities. Today we'll actually be using GitHub Actions, which is not as new anymore, but which is like the new strategic thing when it comes to DevOps at Microsoft. And I think it's going to be great to showcase the capabilities of GitHub Actions as well.
Nice, man. I mean, do you have preferences? I know I'm overtaking the conversation here. JP just sitting there in the background. But, when it comes to DevOps, there are so many different ways to skin the cat. Am I even allowed to say that? Because I think somebody got offended when I said skin the cat. But anyway, there are different ways to achieve the same thing. So let's put it that way. So you have ARM templates. When you work with Azure, anyway, you have ARM templates. You have Azure DevOps. Then you have GitHub Actions. Then you have Pulumi. Then you have Terraform. All these different tools. So do you have a preference about which one you like to use, or is it more of the right tool for the right job? And what's your preference?
I'd like to consider myself polyglot when it comes to DevOps tools. Because I work with so many different customers who have so many different preferences, I can switch pretty quickly between different tools. If I look at my own personal preference, I'm a little bit divided between when it comes to just the language to use to provision infrastructure on Azure. I'm very divided between ARM templates and Terraform, but I have to say I haven't touched Pulumi yet, so that's still on my to-do list. I like ARM templates because ARM templates are the native language, and everything is natively available. And the really nice thing about ARM templates is it's the same language Azure uses at its API level, and you can actually go into the Azure Resource Explorer and see the ARM-alike object, because it's not the full ARM object, but you can see the JSON object on the Azure API surface, and that's just super neat that you, from a user perspective, code what Azure uses. On the other hand, I love Terraform because it's just such a productive language to work in.
Right.
Everybody who's written ARM templates before knows that the template language itself isn't as conducive for very productive programming, because some of the functions and the syntax and just JSON in itself isn't really well suited for very productive programming, which HCL, which is the HashiCorp configuration language, which is the language of Terraform, makes a lot more productive. So I'm torn between the two. But if you ask me if I start something tomorrow, I would just look at the requirements of that project, and then I take it from there and see, will we go ARM templates or Terraform?
Right. Yeah.
So I've got a question on Terraform. Sorry.
Go for it.
So, what sort of how long is it usually from when an API change is made Azure side for either a new product or for a new feature or a new configuration service or surface? How long usually is it between when it's released to the platform and then when Terraform picks it up? Because I've heard in the past that that's sort of been, sometimes that can be an issue, but I've also heard that it's gotten a lot better. So what's your experience been like with it?
I don't want to talk negatively about our platform, but it depends on how well our API is constructed and how well our API is documented and just how well our API works. In 90% of the cases, all our APIs are very well documented and work well. And then it can take anywhere between a couple of weeks to maybe a couple of months, but it all depends on the popularity of the feature request.
Right.
So I'd say couple of weeks for it to pop up in Terraform. I think the good thing about Terraform is it's open source, and if you need a certain functionality, you just open up an issue in the Terraform provider for Azure in GitHub. You open up that issue, people can upvote it, and based on user feedback, the engineering team will prioritize certain features. And if you absolutely need something, which I had a case, it's about a year ago, with a customer of mine who needed a certain feature in the Azure provider in the Terraform provider for Azure, and I just went in and coded it in myself.
Nice.
It took about
Well,
I like
no,
that. Open source for the win.
I mean, I think that's the thing, though, is like those platforms that do, when you're cross-platform or when you're building tooling or an automation with other platforms, the ability for somebody to unblock themselves is sort of priceless, right?
yes.
Yeah. So that's cool. I didn't know that they were. I didn't know that they were open like that, where you could just go and build your own. So that's super cool.
Yeah, and I think the good thing is it's open, you can contribute it back, and that means that instead of just having the Microsoft engineering team working on this, you have all of our joint customers working on certain developments.
Oh, it's super cool.
That's nice. Hey, my experience with ARM templates is always deploy something on Azure via the Azure portal, then reverse engineer the ARM, and then make it enterprises. So you make it, you take away the specific stuff. So I've always gone down that route rather than building ARM from the ground up, because you don't know the dependencies, you don't know exactly what you need. So I always like to do the other way, because many of the customers I worked with, they had no clue how to build ARM templates. And back then there was no Terraform, it was very early days. There was no Pulumi either. So you either had PowerShell or ARM templates to work with. And I always said to them, like, go and create your infrastructure on Azure via the portal, do it one at a time, drag and drop the services, do whatever you want. And then take that resource group, reverse, download the ARM templates, you even get a PowerShell script, the CLI script as well. And then look at the script, look at the JSON file, see what you need, clean it up, parameterize it as well, because sometimes you want to parameterize stuff. And then that's your DevOps pipeline. That was my way, but today we're going to learn a new way, and I'm really looking forward to see how Terraform changes stuff. Maybe I'm going to be a new convert after the end of this session.
Well, I just hope that I can show you some of the productivity in Terraform. I don't mean to convert you, because ARM templates and Terraform for me are on equal footing, but I just want to give you another tool in your tool belt.
Perfect.
So should I quickly switch and try to explain what we'll try to build today?
Yeah, man, the show is yours.
Let's do it.
Okay, cool. Let me open up a whiteboard. I made a draft yesterday, but let me just start from scratch and pull up my surf.
And a whiteboard. I love it. You're dealing with somebody from the field because they have a whiteboard open. Right?
Am I still here?
You're still here on the whiteboard. By the way, did you ever see the app I built that would take a whiteboard and convert it into resources on Azure?
I think I saw that on Twitter once.
Yeah, we should do something about it one day. It's open source; everybody can get it. But imagine, right? You draw something here, and then you say deploy to Azure, and deploys it.
Mm-hmm. By the way, just a question practically. If I disconnect my screen for a second and share a different screen, will that hurt Twitch?
No, it should be fine. Because we have your desktop now. So
Yes.
if you were to just share a certain app, I think it should be fine. I mean, it's Teams, so it's anybody's guess. It's only one way for us to find out.
I'm just going to share the screen on my Surface itself, because I'll be drawing a little bit, and my regular screens don't have touch. So let's just see what it is.
All right.
Let me share the screen.
Twitch doesn't feel anything. It's good.
Okay.
It's not going to be hurt. There you go.
You can still see everything?
We can still see everything.
In fact, it's
cool.
It's changed shape a little bit. So now you've got almost the whole canvas to work with. So that's fine.
Yes.
Oh, cool. Perfect. So let me start with explaining what we'll build. When Christos and I were talking, I had the idea, because this is something I've wanted to do myself, to go in and create a self-destructing self-destructing AKS cluster.
I like it already.
You got 5 minutes before this message gets destroyed. Go for it. Mission impossible.
The reason I've wanted to do this is I once created a template to create a self-destructing virtual machine, just because I do so many demos and sometimes I forget to clean up after myself.
Oh yes.
And I do the same with AKS clusters. Like when I want to do a small little test, I create a cluster, and then a month later I get my Azure bill, and my manager isn't that happy with my Azure bill. So having self-destructing capabilities might actually make me look better in front of my manager. So in order to do this, I had the idea of deploying an AKS cluster through a GitHub action, and then having something in the cluster go in and destruct itself. So in terms of walkthrough, what we'll try to build today is, I think number one is we'll need to create an AKS cluster in Terraform, which will be step number one.
Yep.
I've created a couple of AKS clusters before in Terraform, and you can make it as easy or as complicated as you want. I think for today's session, we'll just go with a very easy cluster, and in Terraform, that will just look like you create a resource group, and then you create your AKS cluster, and everything will be deployed magically behind the scenes. Your virtual network will be created. All of your identities will be created as well. So that'll work pretty nicely. And then step two, after we have our AKS cluster in Terraform, we'll link that up to a GitHub action to go in and deploy the actual cluster.
Nice.
And what that work stream will look like is we'll have our Terraform files that will commit to a Git repo. So it'll be a Git repo. And then from that Git repo, we'll trigger a GitHub action.
Sorry, one quick question. So we've got this concept of a secure Kubernetes cluster and I don't want to call it insecure, but I see them referred to as secure clusters. Like what does that mean exactly in the context of AKS?
Okay, that's something I can quickly explain, I believe.
Okay.
So let me just take a blank canvas. When you think about, let me just call it regular Kubernetes, you've got two things in a cluster. One is you've got, they're still referred to as master nodes. I think they'll have to reconsider those names later on, but you've got the master nodes, which contain your Kubernetes API, etcd clusters, all your schedulers, all your controllers. And you then have your actual worker nodes, which are virtual machines that become Kubernetes machines and that run your actual containers.
Mm-hmm.
When you look at this from an AKS perspective, the top part is a, let's say, a PaaS service or a managed service where you don't see the virtual machines. What you get as a customer is you just get an API endpoint.
Right.
And the worker nodes, those get deployed as infrastructure as a service in your subscription as a customer. Now, what you're asking about is the secure and the regular AKS clusters. A regular AKS cluster, this API endpoint, let's call it regular, that'll be available over a public IP, which means that essentially everybody can reach that API endpoint. That's not in itself an issue because you still have the authentication at a Terraform level where you need to present it with the right token and the right credentials to be able to do actions against it.
Okay.
But like from a security perspective, you typically don't want to expose a Kubernetes master node to the internet because if somebody manages to get your credentials, they can get in.
Right.
And so from, let's say, a defense in depth perspective, we have a secure AKS cluster. We actually make that API endpoint available over a private IP using something we have in Azure called a private link. So I'll just write link next to this, where that API endpoint won't be available over public IP anymore. The only way you can access that API endpoint in a secure AKS cluster is using a private IP using that private link connectivity.
Okay, cool. So you mentioned authenticating and having credentials to talk to that API. Is there any, like, what kind of credentials are they? Like, is it a key file? Is there Azure AD, like, integration available? Like, what does that look like?
So there's two options to authenticate against the AKS API, which is actually just a Kubernetes API, which we make available as a managed service. So in terms of credentials to authenticate to that API, there's two options. One is just using a single key file, which is stored in a file called kubeconfig that I can show you in a second. And what you get with that's also the default, is you get one admin user that gets access to your cluster that's not integrated using Azure AD. So if you have that key file, anybody can log in to your Kubernetes cluster. But in order to get that key file, what you typically do is you run a command called AKS get credentials. And then in order to execute this command in the AZ CLI, you need to be authenticated against Azure, and you need to have the permissions to get that that key file essentially.
Okay, cool.
There is a second way to authenticate against AKS, and that is using AAD integration, where every time you execute an action, or every time you log into your Kubernetes cluster, you'll be presented with an authentication prompt where you go to that aka.ms/ what is it?
Like
device login.
Yeah.
Yes, exactly.
Okay, cool.
And so every time you do a kubectl or a kube control, you need to authenticate yourself against Azure AD, and that allows you to do more fine-grained role-based access control in your cluster, because using the AAD integration, you can link either users or groups and you can give each of those a specific, and sorry, but my Surface Pen is having a bad day today.
No problem.
You can give each of those a specific, come on, role-based access control in your cluster.
So of the customers that you've been working with, do you see, is there interest in the Azure AD integration? Like, is that something that customers are really getting into, or are we falling back to the normal key files because that's what the rest of the ecosystem uses?
In the customers that I work with, most of them are using that first approach with the get credentials, because most of the customers I work with that use AKS actually use AKS in the context of a DevOps pipeline, where they use even something else than those logins. They use service accounts within Kubernetes itself, because Kubernetes has its own definition of service accounts, and they then use those service accounts within Kubernetes to deploy most of their things using what's called a GitOps pipeline.
Okay.
Nice.
The one thing I'd say is with the AAD integration in AKS, that has recently become a whole lot more easy to deploy, because it used to be the way that you had to go in manually and set up multiple service principals in Azure AD and then link those using AZ CLI commands to your cluster.
Right.
Right now, the AAD integration is a lot more straightforward, where it's just a checkbox in the Azure portal when you're creating your AKS cluster, and the AAD integration is done for you.
Oh, that's
Love
nice.
it. So does it create a service principal behind the scenes for you?
Yes, it still creates service principals behind the scenes for you. as far as I know, actually.
Like,
As far as I know.
like you don't have to do it manually, which is great.
So when
Yes, exactly.
so once if I've deployed one of those, let's say AD integrated with the checkbox, what's my experience as as an administrator? I have to go through device login to use kube control or kubectl?
Exactly.
Okay.
You'll still need to do an AKS get credentials, but the credentials you'll get will essentially just repoint. I believe so, because now you're making me doubt a little.
Oh no, I'm sorry. I was just curious. I'm just thinking about the experience.
Oh no, it's a fair question. The one thing I know for certain is your users that get access to the Kubernetes cluster need to get a specific role in the Azure portal that makes them a Kubernetes administrator, so that they have the ability to do a kubectl command that will then prompt them for their AAD login. Once they then did their AAD login, they'll get access to whatever APIs or whatever roles that are assigned to them, so that you no longer have that single master skeleton key that gives you access to everything. You only have access to the things that a cluster administrator beforehand said, oh, Christos can only touch these 3 things.
Okay, cool. So
Right.
it's the difference between a storage account, main key, and Azure AD, RBAC, and storage, right?
Exactly.
Yeah.
Exactly.
Okay. Cool.
So with that detour into those 2 things, let's quickly go back to our pipeline for today, if you don't mind.
Sure.
So we were at the point where we were triggering a GitHub action, and that GitHub action will then use that same Terraform file to deploy the AKS cluster on Azure. And let's say that'll be step number 2 in our pipeline. And just to make you guys happy, there will be something in this GitHub action where we will need some sort of identity to deploy our resources on Azure, essentially. Because GitHub Actions by default isn't authenticated against Azure, and it doesn't use your credentials. It needs a service principal to do that authentication. So we'll show that off later on as well. So that's the GitHub Actions pipeline. And then step number 3, which is not necessarily the final step, but I think this is proving our, let's say, proof of concept that we can create this thing, is creating the, let's say, the self-destruct. And to create the self-destruct, there's multiple options for this. One option could be we could have implemented like a timer on our GitHub action that would, after an hour, 2 hours, whatever you configure, go in and delete the cluster. I decided not to do it this way. I decided to showcase some additional technology in AKS to deploy a. Let me start with what we need to deploy. We need to deploy a pod, and a pod in AKS or in Kubernetes is almost the equivalent of a container. A pod is either one or multiple containers that are always grouped and scheduled together on the same node. And what we need is a pod with a single container in there that will, how will I draw this? That'll reach out to the Azure API to essentially say, delete this AKS cluster. To do this, again, for this step, we will need identity as well. And there's an interesting piece of AAD integration in AKS, which is called, let me draw that here, which is called AAD pod identity. Come on, identity.
I think your pen is running out of juice.
Yes, I think the issue is, I don't know if you can see this on camera, but my tip is broken a little bit,
Oh no.
and I think this is messing with the pressure sensor in the pen.
Oh no.
So I
Right.
already ordered a new one, but I haven't gotten it yet. But that's AAD pod identity, where with AAD pod identity, we use something called MSI, or managed service identity, in the background to give an identity to each individual pod on the Kubernetes cluster. Because if you take it one step back, and please help me if I'm going too fast,
No,
but
no.
we have a functionality in Azure with MSI, or managed service identity, or just managed identity is what it's called right now, I believe.
Yeah, there's no more S in there.
So
Managed
MI.
Identities. Azure Managed Identities. That's the correct name, apparently.
And AMI? Are you serious?
AMI, yep.
I see. I've always remembered it as managed service identity, and I'll probably call it that and make people cringe. But there's another cloud that uses AMI as a pretty well-known acronym.
I've been told that it's not AMI but AMI.
Oh. Me.
Come on. No potato, right?
I mean, we love MSI, so that would be appropriate, right?
But MSI was so confusing as well. Like, are you talking about the installer? MSI, the installer? I
Is
remember people were so confused in the early days.
Who's actually talking about installers in 2020? Come on.
Who doesn't talk about installers? How do you install your stuff on your Windows machine?
Chocolatey.
Oh,
Yeah,
I knew
exactly.
you were going to jump with that. I'm surprised we don't have someone on the stream saying chocolatey.
We did a few weeks ago.
I mean, we love our friends and chocolatey, but sometimes it's just like, I want to go to the website, download the stuff, and run it. Like, I installed PowerShell the other day via MSI. So PowerShell 7.3 or whatever it is, the last version.
Whatever we have to do, and I don't want to be negative against Microsoft, but I hate going through the Microsoft store to get something installed.
Yeah.
See?
You know what? I couldn't install Terminal the other day, so I had another VM. I spun up the other VM because I was doing some Java stuff, and I wanted to install Terminal. It just wouldn't let me. The store was like, no, your account does not work here, or I don't know. I spent an hour of my life trying in vain to get Terminal installed. Like, you know what? Screw it. I'm going with Zcell and whatever. It was just insane. Store.
Back to our AMI, or our Azure Managed Identity, as we have to call it right now. What you can do with Managed Identity is you essentially register your virtual machine in, let's call it AAD, where your virtual machine itself will get an identity in Azure Active Directory, where your virtual machine no longer needs to have a username password to authenticate itself against Azure AD. There's an internal endpoint, which I'll just call the managed identity endpoint in this drawing. And it's actually something called the instance metadata service, if I'm not mistaken, available at a 169 address somewhere. And you'll see this, if you stay tuned, you'll see this further down the line in this demonstration. But the VM makes a call against the managed identity endpoint, which will return a access token in AAD, which the VM can then use to do whatever it has to do and do its actions. Where things get interesting with AAD pod identity is, and I'll quickly wipe away my AMI, is in an AKS cluster, you have multiple pods running on a virtual machine, which is a Kubernetes worker node. Yeah. And those different pods can be different applications. One pod could be your web front end. The other one could, for instance, be your database. And because of Kubernetes magic, you never know which pod will run on which node. But you might want to give your database certain credentials to access, let's say, let's just say, for instance, Cosmos DB. Mm-hmm. But you don't want your come on, why can't I write a B? But you don't want your what you don't want is you don't want your web front end to be able to access Cosmos DB. If you were to just give a managed identity to the VM in your cluster, both your web pods as well as your database pods could be able to get that token. what AAD pod identity allows you to do is with AAD pod identity, there's actually two controllers running on the VM, and I'll just draw PI as pod identity, which will intercept each call to the managed identity endpoint, and then validate if those pods have the access rights to get those tokens, and it'll only return the token to those pods that are authorized to get them.
Oh, nice.
So I have a question now.
Okay.
How does that scale? Like if let's say I have 30 pods because I have a microservice architecture that has a lot of different components there. Do you have to manage those 30 managed identities and then remember to delete them once your cluster dies? Is that going to be part of the self-destructive process, or you don't care about the managed identities at this point?
In the thing that we'll build is both the and I'm almost running out of colors. Both the cluster as well as the managed identity that we will create will be part of our Terraform file.
Nice.
So we will link our pod to a single user-defined managed identity, and what the delete action will actually do is the delete action will not delete the cluster. The delete action will delete the resource group that the cluster is deployed into, and that resource group also contains the managed identity. So we're making everything clean, and we're really cleaning up after ourselves.
And for people that are following around on this conversation, you have system assigned managed identities, which are automatically assigned to your resources and are tied to your resources. So if you delete a resource, the system identity gets wiped out, and it's not something you manage yourself. But the user-defined identities, again, it's a managed identity that you have defined yourself. You have a lot more control over it. You need to manage the lifetime because it's not tied to a resource. So that's why I was asking, just to make sure that we're doing the right thing and we're not forgetting user-defined identities behind.
Yep. No, we're deleting those as well.
No managed identity left behind. That's the motto.
No army left behind.
No army left behind.
What have I gotten myself into?
Sorry, I should have warned you. I should have warned you beforehand that we'll be asking the stupid questions, right? So.
Oh no, I'm making an ass of myself by calling AMI army, but
No, it's okay. I'm gonna start calling it that from now on. That's what we're gonna refer to it.
It's trademarked now. Yeah. It's copyrighted. We're allowed to use it.
If you want to go on a tangent, there's this guy called Corey Quinn who even sells T-shirts that say it's pronounced. I don't know if I can find it.
I love Corey Quinn. He's so funny. His Twitter is like.
How do I not know about Corey?
Oh man, you're missing out.
I must be.
Oh, he's
the only Corey I know is Corey Sanders.
No, this guy, he's an absolute riot. So.
Yes,
he's not Microsoft, right? So he just does.
No, he's an independent.
Yeah.
It's pronounced Ami. He actually has a T-shirt, but that's for AWS.
Well, yeah.
But there's two T-shirts.
Oh.
There's Oh no, there should be another one that says it's pronounced AMI, but I didn't find that.
It's pronounced AMI. Yeah, I see that one. It was like a charity shirt.
Yes. Where's the other one?
That's pretty good.
Yeah, let's not get bogged down into AWS things, but it's an interesting debate, and if we want to stay on the Corey Quinn thing for just another second, he doesn't pronounce GitHub as GitHub. He pronounces it as GitHub.
Oh no!
Oh come on! My eyes and ears hurt now.
Yes.
That's awesome. GitHub.
I'm okay with the army. I'm not okay with the GitHub.
Well, you know what? People can agree to disagree here, because I think the younger generations are okay with GIFs and GitHub, but I can't fathom it. Like, it's hard, so hard.
Mm-hmm. So going back to our self-destruct script, we have this pod that'll delete the resource group and the cluster. But if we just create a pod itself, that pod will run immediately, and you might want to use your cluster for a certain time. So we won't create an actual pod. What we'll create is we'll create something called a cron job in Kubernetes, And for those familiar with Linux system administration, you'll know what cron is. Cron in the Linux world is a scheduling system that you can use to run scheduled tasks. It has a certain way to notate timings, where there's, I think, 5 levels at which you can define time for cron. One is the minutes, the hours, the days. I think then the month and the day of week, I believe. Don't take this for reality, but you'll see this in a second or later on the stream when we actually deploy the cron job. And what a cron job does is a cron job creates a Kubernetes job. And a Kubernetes job is nothing else than a way to create pods that will finish a certain task. And that's what we'll do. We'll create a cron job. The cron job will then, in the end, deploy our pod, where the pod has the pod identity, which will then go into Azure and delete the resource group. And
Nice.
the timing itself, we can create this via cron itself. So we could create a timer that would delete our cluster after an hour or after a minute, or it'll delete our cluster on Sundays. Whatever you want to do is possible using that cron job.
Nice. I mean, coming from my old field days, I think there are other ways to achieve this, but I don't want to ruin your mojo here. I was thinking, like, you could do Azure Functions to delete resource groups, right? So you don't have to do it via Terraform or GitHub Action. And then there was Azure Automation. Is that still a thing? Do we have Azure Automation still running somewhere? You can create
Azure
runbooks.
Automation is still running, and Azure Automation has been successfully shutting down my VM since 2016.
Very nice.
Nice.
I need to intervene only once a year when my certificate for my Surface Principal expires.
Nice.
Sweet.
But
there you go.
Christoph, to what you're saying, what we're doing today is definitely overkill to delete a cluster. Because if I were doing this for real, I would also use either an Azure Function or Azure Automation to go in and delete the cluster, or even do something in GitHub Actions to go in and delete the cluster from that action. I wouldn't do that from my cluster, but it's a cool demonstration case today to actually demonstrate AAD pod identity and showing off how you can use those identities to make an Azure API call.
Absolutely. So I was not calling you out on that. I mean, I'm just saying that there are other ways. If people are asking, like, why is he not using functions or whatever to automate stuff? So I love Azure AD pods. Let's do this.
Okay, cool. There's a fourth step that I might consider if we still have time, but given all of the tangents we've done today, I don't think we'll get to step 4.
That's all your fault, Jake. You're asking all these
That's
questions.
a very nice way of saying you guys talk too much.
Well, it's a fun way to wake up, I'll say that. And the fourth thing I would love to do is a GitHub action, a GitHub issue integration, where we could, if we go back to step number 2, right now the GitHub Actions is triggered every time we check in our Terraform file or a file in our GitHub repository.
Right.
It would be nice if instead of triggering this at a file check-in, it would be nice if we could trigger this based on a GitHub issue that's created, and you can define in GitHub Actions who can open, or based on the user that opened the issue, if the actual action would be triggered, so that if this is open source, that not everybody could come in and start creating clusters, and then my manager would be unhappy again. With the issue integration, it could just be a nice way for me to open an issue, tell GitHub I need a cluster for, let's say, for 6 hours, and that then the GitHub action would create the cluster for 6 hours without me having to go in and write code and just open an issue. But that would be a very nice to have step 4 if we get to it.
That's nice, by the
Nice.
way. I like
it's
it.
like GitHub as a durable message queue.
Yeah.
GitHub issues as durable message queues.
Yeah, just give me 1 sec, because I just got a battery low notification on my headset. Let me plug in a cable. Just 1 sec.
Sure.
Oh, the modern day issues.
Yeah, that's okay.
My headset's
No, it's okay.
that's why I decided to use a cable. So my Bose headphones do have wireless, but I think that with a cable it just resolves that problem, so you don't have to ever
I'm gonna have to
load.
I'm gonna have to find some other earbuds because these hurt. I mean, they sound nice, but they hurt. It's like we're 45 minutes in, and my ears are already sore from these bud things. I don't know. I gotta find something else.
We should request custom earbuds that are are made for our ears specifically.
Like it's like studio monitors. There's like live music monitors that form.
It's only 2,000. I mean, we're worth it, right?
Well, don't you guys say that you're on video for 6 hours a day? So you might be able to convince your managers to give it to you.
That's just talking to each other, though.
Yeah, it's true. I mean, we're only talking to each other, so technically it does not count.
Well, it all depends on the way you sell it.
True.
But that's what I wanna. That's what I wanna build, and I'll be very happy if we reach step number 3, and then we'll just see what time it is. If we can still do step number 4.
Yeah, love it. Show me some code.
With that said, we want to get started.
Why don't we take a short break, just 2 or 3 minutes, just to get drinks refills as we're about to start building. So we will be back at, I guess let's say we'll be back at 10. I don't know, 10:50, 10:53, 10:54. We'll be back in 4 or 5 minutes. How about that? And
4 or 5 minutes, yeah.
Yeah, and we will
some coding.
And then we'll do some coding. We'll jump in and start building stuff, right? Cool.
Yes.
See you in a few minutes.
Cool.
Okay, everybody, we are back, and we're ready to start building something, right?
Yes.
I am.
All right, let's go.
Okay, cool. I think to start, let me just move my laptop around because I no longer need the touchscreen. To start, I like to start off because we'll be using GitHub Actions in a second. To just start off by creating a Git repo at this point in time, because I always have issues if I do a Git init locally and then push it to GitHub. I always have issues with the base, so I just like to start off with a repo here.
What?
And
Why do you have problems?
because Git is hard.
Yep, I felt that one in my bones.
Okay, so
I wanted to do a session on Git one day. Just look at basic Git stuff.
The one thing I'll tell you is Scott Hanselman has been doing these computer stuff they didn't teach you in school series on YouTube.
Yeah.
And he's been explaining Git, and like it's been enlightening because he explains it so well in like 10-minute videos that if you want to learn something about Git, either have him on or look at those videos. But I think it'd be cool to have Scott Hanselman on here, don't you think?
Always.
Yeah.
So I'll create a public repo so anybody who wants to follow can follow along with me. I'll add a git ignore.
That's why you can do Git init first. If you are creating your repo like that, then it already has files there. So when you try to sync, you will say, oh, well, you can always do git push force and override everything. But you don't want to do that, obviously.
Could you zoom in just a little bit too, when you get a minute?
Okay. Is this better?
That's a good point.
Yeah, I think that's okay.
Okay, cool. So I'll go ahead and create this repo. And then once we have that repo, we can copy it into my local machine to start developing. So what I'll use to do the development is I'll use Windows Subsystem for Linux from the Microsoft terminal. If you're interested in this setup, some shameless self-promotion, but if you want to have the same thing where you even see the branch name that you have in GitHub, and this turns green if you're all synced up. This turns orange if there's uncommitted changes. I actually have a blog post live, which is my most popular blog post for some reason.
See, our audience is always weird. My most popular one is how to reset your GitHub credentials, your Git credentials on Windows. I kid you not, I get like 150 hits a day because people expire their credentials and they have no idea how to do it. So promote away, my friends.
I have the same thing. This post on setting up WSL2, Windows Terminal, and OMyZSH. And OMyZSH is just to get the nice terminal colors. I think I get like you said, 150, 200 views a day on this post, and then all of the other posts, which took me like days to write, get like 2 hits a week.
I know, it's insane, right? But it's what the community finds useful. So don't feel bad about yourself. I used to get one about WinForms, dependency injection with WinForms, web forms back in the day, and that was insane. It was just like I spent so much time doing .NET Core and other stuff, but I had a project. I was working as a consultant back in the day, and I had one of the projects was web forms back in the day, and I had to do some web forms work, and I did dependency injection, and apparently that became so popular that I was like, oh my god, I feel the same. Like I feel dirty right now. I need to go and take a shower.
The thing is, you see what's popular. You don't write for what you think is interesting. You need to write for what the audience wants, and apparently the audience wants to learn how to set up WSL2, Windows Terminal, and OMyZSH.
Yeah.
So
besides, if you want to set it up next time, you know exactly where to go. Back to your blog post.
That's why I wrote it. And I already made a mistake here, so let me get out. And let me show some other cool thing in Windows 10 is instead of doing paste with Control V, You can do a paste with Windows key V as well. And then you get like clipboard history, and I can just go back into my clipboard and not have to copy paste the previous thing.
Kaboom.
With that being said, let's go into our AKS self-destruct folder and open VS Code. So to open VS Code in WSL 1 or 2, it doesn't matter. You can just type code dot, and this will open a VS Code window. And with that, we're all set up and ready to go. To start today, if you remember, step 1 was just creating an AKS cluster in Terraform. So we'll create a new file called, I'll just call it aks.tf. TF is the file extension for Terraform files.
Do you have an extension inside VS Code for Terraform?
I have it installed, I believe.
Okay. I wonder what kind of support or help you get out of that because of the extension.
It does syntax highlighting, which is very nice. And if I'm developing something custom, I actually haven't used this when I was preparing for this, but it can also do some suggestions for like variable names to use, and it is pretty useful to have this installed, if not only for the syntax highlighting, just to show you what's up and what's working or not working.
Cool.
But first thing we need to do every time you create a Terraform file is the first thing you need to tell Terraform is which modules to import. And what I do for this is I typically just do a Bing search for Azure Terraform to get to the latest page using Terraform with Azure.
So is this something that Microsoft maintains? Is that a community project, or is that something that HashiCorp maintains? Do you know?
So the provider itself is maintained by Microsoft. So
Nice.
it's an open source provider. I think HashiCorp has some level of feedback that they provide into it, but the provider is actually owned by Microsoft.
So it's an official provider. If people are asking if I should be using Terraform or if that's something supported, we support it. This is our project, or more or less maintained by Microsoft. Great.
Yes, it's a project maintained by Microsoft. I'm always very hesitant with the word support, because support can mean two things. Support,
True.
On the one hand, can mean does it work? It could also mean does Microsoft provide support for it? I think on the one hand, support, does it work? Yes. Does Microsoft support provide support for it? Also, yes, but because it's an open source project, there's no SLAs about the support, and it's let's say best effort support, because it's not an actual Microsoft product; it's an open source project. But let's go into the first step, which is getting your provider to work. And what we need here is we need this thing. We need this provider feature. So this is what we'll use. And I'll just copy paste this block in here. So what this does is this tells Terraform we'll use the provider Azure RM, which is Azure Resource Manager. And we'll tell it to use a version bigger than version 2.0. The one thing that I actually like to do is I like to hard code the version that I use, so that if there's evolutions in Terraform and there's potentially some changes, I like to actually hard code this version. So if you'll bear with me, I had a look yesterday, so let me just.
Also, can you zoom in a little bit on the both on the terminal and the VS Code?
Yes, I can do that. So.
Because I've got old eyes and I'm getting old, so but can you not do Control Window in the terminal and zoom in?
I don't think you can do it on the terminal. Oh, you can. Okay.
Haha!
Cool. I learned something new today.
Learned something new today. I contributed to society. There you go.
Yeah. So what I was telling you is I'm going to copy this version just to hard code the version in so that if things change, my module won't break. So I'll just copy paste this in because that's the latest version. And with that, we're all set to start the work. And the first thing we'll create is we'll create a resource group because we'll need a resource group to deploy our cluster into. And to get a resource group, we can use the same quick start because it has a resource group in there. Just copy paste this in here. Azure RM resource group, we'll need to give it a name. And I'll call this, for now, I'll call this AKS, let's say SD for self-destruct, but give myself a note to do, make this dynamic. The reason I want to make the resource group dynamic is throughout the course of this working together, as well as when I'm creating these clusters afterwards, I might have multiple clusters running in parallel. And if we create them all in the same resource group, that would conflict. So I'll create a new resource group for each cluster, and I'll add the time of day in there in a second. But let's just start with the most easy deployment for now. And because this is closer to my home, I'll deploy it in West US 2. And with that, we can get started and actually start deploying things in Terraform. There's two ways we can now start and go ahead and deploy this. One option would be to use the built-in terminal into VS Code. This is a good way to do things, but I actually prefer just flipping back to my own terminal and working from my own terminal for some reason. So what we have to do now is there's a Terraform init. This is something you have to run once with Terraform, and what Terraform init does is it'll pull down all of the modules that you're using. So in our case, it'll pull down the latest version of the Azure RM resource provider, and it'll just make sure that we can use Terraform. This init thing is something we'll do just once. So let's hit the enter button. So it'll download that provider.
Oh, it downloads automatically. Nice.
Yes, just Terraform init. You run this once, and then next thing is we'll do Terraform plan. I like to provide an output file for my Terraform plan because then it's a little bit easier to do the Terraform apply afterwards. Right. You don't have to do this step, but I just like to do it. You do Terraform plan, and this will check with Azure what exists already. And it'll then make sort of a graph of all the things that need to be changed in the apply step for the resources to be deployed as they are. Now, one thing you might have noticed is I haven't logged in yet, but this works. What Terraform does on the client side is Terraform looks for the credentials that Azure CLI uses as well. And as you can see, I'm already logged into the Azure CLI, and Terraform uses those same credentials to access the Azure API as well. So what we're seeing here is an execution plan has been generated, and what we'll do is we'll create a new resource group in location West US 2 with this name, and the ID of the resource group will be known after the apply. And to apply, we can just do Terraform apply plan.out. So if I put this in and do enter, this will then go in and start creating my resource group. So if we give this, shouldn't take too long, I hope. We should see this resource group being created. Resource group is created. And if I then were to go into my Azure portal,
Does Terraform work synchronously with the deployment process? So if you say Terraform apply and you apply like 10 VMs, which may take 10 minutes, does Terraform spin while these things are happening in the background, or does it show completed and then you just have to wait for the resources to turn up?
No, Terraform will actually wait for everything to be deployed, and you can follow along at each point in the process to see what Terraform is working on and what's deployed and what it's waiting for. So here you can see this, and let me zoom in again. Keep reminding me to zoom. We have our AKS SD resource group that we just created, and this was created through Terraform. I'll do one final thing to showcase some Terraform capabilities. One capability that Terraform has as well is Terraform maintains a state file. So if I were to have a look now, you'll see this terraform.tf state file. Right now, this state file is stored on my local system. If you use this in like a production system, you would store this somewhere in external storage, for instance, in an Azure storage account or in like the Terraform cloud service, because we're now using the open source version of Terraform, just the free open source version. HashiCorp, HashiCorp is the company behind Terraform, also has a commercial offering. And with that commercial offering, you can have your state files stored in a managed service, which will mean that multiple people. Sorry. Am I still here?
What was
You're
that?
still here. What was that?
That was a public safety alert.
Oh.
Oh, is it? Wow.
Going off of my phone, and I just hope that I don't have to evacuate because there's some wildfires going on in California.
Oh my God.
Oh,
Are you okay?
yeah, right.
How?
I am okay. I think the only issue that I'm faced with is we have terrible air quality right now, which means that I've been locked up in my house. And I had a week of vacation last week, and since Wednesday I've been cooped up inside because it's just dangerous to go out right now. But I'm far enough away from the fires to not be impacted. But they're very close by. I've had colleagues who had to evacuate because they were in the middle of the fire, and it's crazy right now in California.
Wow. Well, stay safe.
Yes, thank you. So no alert for me. I was talking about the state file. You can store that wherever you want to store it. The good thing about the state file is that you can also use the state file to destroy what you just created. We won't be doing this most of the time today, but if I were to do Terraform destroy, it would actually go ahead and destroy all of the resources that it had created before. So if we give this a second to run, we should see it go in and delete our resource group. Only type yes, so I will type yes. Just a failsafe. I will type yes, and then my resource group will disappear in a couple of seconds.
Oh, come on, man. We just created it. I'm just kidding.
Yeah, that's fine. I mentioned before that I wanted to have resource groups with a dynamic name. Reason I want the dynamic name is because with the dynamic name, I'll have the benefit that I'll create a new resource group every time I execute this. And because we'll be executing this very frequently, having a dynamic resource group name will be very, very useful. I don't want to bore you to death with figuring out how to include a date timestamp in the resource group name. So I'll just cheat from what I built yesterday. I'll explain what we're doing, but let me just copy paste this in. And
so that looks almost like a function in ARM templates, right? You have specific functions that allow you to do stuff. Is that
yes,
correct?
Exactly.
Got it.
So what we're doing here is, let me zoom in a little here as well. No, Control plus. And close the terminal. So what we're doing here, instead of doing a static resource group name, I'm doing a format of two strings. I'm just $S, two strings, where the first thing is AKS self-destruct resource group. And then I add just the current timestamp with year, month, day, hour, minute, so that every minute I would create a new resource group. So if I were to want to run this, let's hope the previous one successfully deleted. So here you can see my resource group was destroyed. And Christos, to your earlier question, you can actually see here that
Nice.
Terraform waits until the actual delete completely happens. So if I now want to run the same thing, I can do Terraform plan. No need to run the init again because I'm still using the same provider. But if I do Terraform out plan.out, and I hit the enter key, it'll create a new plan. And what you'll actually see in the plan is you won't see the resource group name anymore. It'll tell me the resource group name will be shown once the apply action has been taken, because there's that dynamic date in there. So if I now do my Terraform apply plan.out, this will go ahead and create a new resource group with the name including the date and the hour and the minute in there. So that's that. So if we go into the portal and we go to resource groups and we refresh this view, oh, come on.
It's okay. It's okay. Takes a second.
Yeah, it should be there because it says it's created.
Are you in the right subscription?
I am in the right subscription. Let me do a hard refresh. This is what I always blame the demo gods for.
Exactly. That's what they're for, to be blamed.
Yeah, here it is. So we now see this resource group with the date timestamp in there, which is useful because we'll be creating a lot of those throughout the course of this work. So we now have a resource group. Next thing we'll need to do is we'll go ahead and create a Kubernetes cluster. So the way I typically do this is I just do Terraform Azure RM Kubernetes cluster. Let's just use the Bing search instead of using my history. Here we actually get to the documentation by Terraform. This documentation is very interesting. They do, or Terraform does almost, I can say exactly the same thing as the Microsoft Docs teams do. All of the documentation you see in here is maintained on their GitHub repo. So if you see an error in the docs, you can just go in and make a change. The downside is if you make a commit to Terraform before they accept that commit, you'll also need to document the changes you made, which is good from a coding practice.
A bit of an overhead.
A bit of an overhead, true, but you need good documentation because without documentation, your audience will be stuck.
Yeah, I wish we followed that for everything. Like every time you write software, you need to have the right documentation and keep it live.
Yeah.
So that's you copy that into.
Yeah, I just
file,
copied
right?
the example. We'll be changing this a little bit because I don't like names example in here, which is typically what you see in Terraform. I just like to call this, let's say, APS SD, because that's what I'll call the cluster as well.
Where's Contoso? I'm expecting Contoso somewhere here.
Let's just call it Contoso.
Peer pressure. I have a question. Can you assign the date format that you had before into a variable that can be used afterwards?
Yes.
Like sometime. Oh, nice.
Actually, need to be very careful because I think the truthful answer is no, because variables in Terraform need to be hard-coded. You can't use, if I'm remembering correctly, because I tried this yesterday,
Okay.
I believe variables in Terraform have to be hard-coded and can't be something
Dynamic.
Dynamic. So
right.
let's see if we can make this work. So if I just do RG and RG here and remove the output because we won't be using the output itself.
Okay. Can you reference? Oh, you can do. Oh, right. Okay. Can you do RG? Oh no, that would be the RG name. So you take the whole thing. I was wondering if you can have RG date or whatever as a variable, but that's not.
You can define variables, and let me just have a quick look how Terraform does variables again.
See, I told you that's gonna take a long time to build.
Oh no, that's fine.
Because I'm asking all the questions here.
So this is how you do a variable.
Okay.
Let's do one with a default value. We can just do default equals. So if we do this variable type equals string, and then maybe that was the issue yesterday. Can I just do value equals? I don't know if I don't think what I'll do will work, but let's give it a shot. And do this, and then do Terraform plan out plan. This doesn't work.
See,
Value
yeah,
is not expected here.
It's fine. It's fine.
Let's see. 1 second. No, there's a default.
No harm in asking and breaking.
No, there's
stuff,
no harm
like-
in asking. Somebody might know how to do this, but I didn't figure it out yesterday, so I'll just put that in not hard coded, but I just used the variable here. And then what we're doing further on is we're giving a name to our cluster.
What about a local value? Because it looks like here. It's in the. I'm looking at the Terraform.
Somebody just mentioned that.
Look at the Terraform docs, and there is a. Oh, see. Thanks, Mr. DT. I think locals look like they kind of look like what you're trying to do. Let me put it in our chat here so you can see it. They look like essentially local variables. So you can set a local to an expression value and then reuse it over and over again.
So let's see. Local service name owner. Huh. So if I do locals and I'll say RG name.
So Terraform locals are equal to ARM variables. Interesting.
And then do this. And then instead of name, we'll do locals.rg name, I assume.
Or it might be just RG name because it's a unique variable or something.
No, it's just local, not locals. Just a singular.
Oh, it's local.
Yeah.
Okay. Let's do local.rg name. And then do a plan again. Yeah, this seems to work.
Nice.
Check that
On
out.
pins and needles. That's awesome. Thanks, Donnie.
Cool. So that's why you do live coding.
Yeah, but we'll learn on the go. That's the beauty of it.
I feel like I should just
Yes.
treat myself working all day so that other people can tell me where I'm doing things incorrectly. I mean, it'd be busy.
You will be surprised how many people do that. Like 8-hour stream of somebody building something, and then the audience helps or the viewers help with, like if you get stuck somewhere, they help out.
We know.
It's great.
You know, they say the fastest way to the right answer is to be incorrect on the internet, right?
Well, the one thing about the internet that I'll teach you is somebody will always disagree with you.
True. But you have to have a thick skin and an appetite to learn, and sometimes you get some really good stuff out of there.
Absolutely. So back to this. I'll keep this local in here because it's a nice way to clean up this resource definition. What I will keep is I'll keep referring to the resource group name in the Kubernetes cluster definition by the actual resource group.rg.name, so that if ever we change something, we just have a dynamic link to the resource group and not to the local definition. What we're doing here is we're passing the same location as the resource group to the Kubernetes cluster, and we're passing the resource group name dynamically. We also have a DNS prefix, and we'll call this Contoso AKS as well, just to make Christos happy. We have a default node pool. This is all fine. It can be called default. I don't really, do I care? Nah, it doesn't really matter. It's called default. And we have one node in our cluster of the type D2v2. The thing with AKS is you can use, I believe, all of the VM SKUs on Azure can be used for AKS. So if you want to use SKUs with more CPU, more RAM, more compute, even some of the GPU instances, you can use those in your cluster.
Maybe we should use.
And
We
then-
got let's use like an M64S.
I will if I can use your subscription. Maybe you won't believe me, but yesterday I even got an error message when I was working on this telling me you have exceeded your core quota. That was how many clusters I created over time.
You don't want to get those emails, by the way.
Nope.
I think in the UK it was a 20K limit per month. So if you hit that limit, then I mean you can still keep working, but you had to justify it. So
Wait,
spinning up.
You got 20K to spend per month internally in the
Yep.
UK?
Yep.
Per person?
Yep. Yep, I think so.
I mean,
that's a lot because I think I get either $1,000 or $2,000 a month, which is more than plenty for my purposes.
I can check with my UK colleagues just to make sure I still remember it correctly. It's been 2 years and I'm getting old as well, so it could be just me getting things wrong. But I remember getting an email for 20K because overspending on my subscription for a month, and I had to justify why I was that high. I can't even remember why I was that high, but I must hit it.
Because you forgot to turn off your VMs.
I need a self-destructing Terraform task to do that. Please tell us how to do it.
Yes. So next thing here is you'll see identity of type system assigned. In AKS, you need an identity for your Kubernetes cluster so that your Kubernetes cluster can create the resources in your subscription.
Very nice.
What you see when you create a Kubernetes cluster, and let me show you because I have one already. Where's my portal? I lost my portal somewhere. So if I go into the portal, I have one or maybe two Kubernetes clusters right now that I have running that are not self-destructing.
Okay.
So if I were to go into resource groups, the resource group that it's hosted in is the resource group AKS service test, I believe. Come on, I'm not that patient. So you see AKS service test, and if I were to do AKS service test as a lookup for resource groups, you'll see that I have a second resource group that's MC. I've always assumed that MC stands for managed containers, but if anybody knows differently, I'm open for the feedback. AKS service test, which is the resource group name, underscore service test, which is the cluster name, underscore location. This is the resource group that gets created by default. You can tell AKS as well to create a new resource group with a name that you prefer. So we could actually tell it to create a resource group Contoso with the date added to it or whatever we want to do. I'll just use this default naming because it works well and it keeps our Terraform file pretty easy. But the reason I'm showing you this is your Kubernetes cluster needs some permissions to create stuff in this resource group. And what you'll see if I show you the activity log here for, let's say, the last month, I believe I worked on this in the last month. You should see that there are some events in here where the event is initiated by some service principal with the AKS name in there. And yeah, so we'll see. I actually don't see the events that I'm looking for, so I'm sorry for that. But I'll show you this later on, that there will be events initiated here by a service principal that needs access to this managed resource group to go ahead and either deploy new things, create load balancers, or just make your Kubernetes cluster work. Initially, this identity was a service principal where the credentials of that service principal were stored on your nodes in your Kubernetes cluster, which it's fine, but which was not perfect.
Yep.
Having this system assigned managed identity now for your Kubernetes cluster is actually super great because there's no more credentials that are stored. Your AKS nodes just do a call to the MSI or the AMI endpoint, the Azure Managed Identity endpoint, and they then get a token and they can use that token. So no more credentials, a lot safer. And tags, finally, I actually don't care about tags for this use case. So this is all I need to go ahead and create a Kubernetes cluster on Azure using Terraform. There's a lot more options you can do here, and if you were to do this in a real production setting, you would actually put a lot more options in here. But for our use case, this will do. So now that we have this, I can actually go ahead and do a Terraform plan.out. And this will recalculate the state, and it'll show me what it has to do. It'll actually also show us that it will go ahead and delete the existing resource group that we created, this 1513 one, which I believe we still had there. And because we are now 16 minutes further along, it'll actually create a new one. Okay, so that's that. You'll see the resource group must be replaced, and we will create a Azure RM Kubernetes cluster. So let's go in and do the Terraform apply. And the first thing this will show us is it'll delete the previous resource group.
Does Terraform do things like with ARM templates where you can do check only or what if you wanted to without actually deploying the resources?
That's actually what the plan does. The Terraform plan is that what if, because it shows you all the actions that it'll take.
Right. And do you also do incremental deployment? So if it finds something, it doesn't override it and then just goes and creates new stuff?
Yeah, exactly. That's all built in by default. In our case, it actually won't do this because our resource group name will increment with time.
Right.
But yesterday, when I was doing some tests, I at a certain point removed the date time in there to work in an existing resource group. But this works pretty well. I for the interest of time, I propose we don't watch this destroying and rebuilding the new stuff. What I actually would like to do now is add these files to GitHub and then start working on a GitHub action to create this.
Perfect. Let's do this.
So there's two ways to commit these changes to Git. I could just do this manually in my own terminal. And if I go into our self-destruct folder, I can do a git status, see that we have two files in here that would need to be pushed. One way to do this is just do git add, git commit, git push. You can also do this straight from VS Code, where you can actually specify which files you want to add. And this plan.out file actually doesn't need to be added. And to do that, we can update the git ignore file to ignore .out files and just do.
Is that because our build pipeline will generate the out file and then automatically deploy it?
Sort of, yes. Okay. The thing is, the out file is just generated content, and you don't want your generated content to be part of your Git repo.
Sure.
So I'll specify the ignore of this .out file, and then I'll add my git ignore file to state changes. I'll add my aks.tf as well, and I'll say aks using tf as my commit message. Now some magic will happen, because once I do this, you'll notice here in the bottom that my VS Code automatically starts pushing codes. This is an option in VS Code that I discovered yesterday. So if you go into your settings, there's a git push. No, it wasn't git push. What was it again? Oh, come on. I discovered this yesterday, and this was super cool because I always forgot to do my git push in VS Code. But there is an option in VS Code to push automatically every time you do changes.
See,
Alright.
there are certain things that I don't like about GUIs when it comes to Git because I want to have full control about what happens and when.
Yep.
So I'm one of these guys that are always on the console, and I avoid GUI tools for Git. Don't at me, or don't come at me anyway.
That's fine. It's Git post, by the way. I would not recommend this if you're working on a certain branch with multiple people, because if you're working on the same branch with multiple people and you do a sync every time you do a commit, you might interfere with other people's changes. But if you're just working like we are right now on a single repo, this is a really nice way to avoid forgetting to push and thinking that your action is running in the background, but your action isn't actually running, and this will avoid us to lose a lot of time. So it's just an interesting setting I found yesterday. And now that we did our push, if we go back to GitHub and we refresh, we should actually see that we now have our aks.tf file in here. And based on this .tf file, we can actually start and build our GitHub Actions pipeline. So let's go ahead and do this. We could be very creative and start with a simple workflow, which is basically nothing. But I am very lazy, and I'll actually just use the default Terraform action by HashiCorp.
Aren't we all lazy? I mean, developers try to find the easiest way and less friction. So go for it.
A lot of comments in here which we won't read, but you see the name is Terraform. We can actually call this self-destructing AKS cluster as well.
Mm-hmm.
It'll run every time there's a push on the master branch. Since this is a demo, we're only working on the master branch, so that works perfectly fine.
This is YAML, by the way, right?
Yes,
Just for
this is
people
YAML.
that are, yeah.
Yeah, and just to make it easier,
I see JP just cringe a little bit there. I said YAML, I was like, oh my god, because he loves YAML.
No comment.
Don't we all? Wait until we're a bit further down the pipeline, and I'll make your eyes bleed a little.
That's the best way to start Tuesday morning.
Yes. So we're running Terraform. We're running this on an Ubuntu latest GitHub Actions runner in a Bash shell. And what this action does, I haven't written any code yet, is it does a checkout. It then does a setup of Terraform, and it actually uses a CLI config to, if you actually check the documentation, it logs into Terraform Cloud using a user API token. We are not using Terraform Cloud right now, so we actually can remove these two lines in here, because otherwise, because we're not using the Terraform Cloud, we can't use it anyway, so we just need to get those two lines.
If I remember correctly, GitHub Actions work with Azure AD for deploying to Azure. Is that something you're configuring now or later? Or is that already configured?
I'll do that in a second. I'll show you how to do that in a second.
Sorry, I'm getting super excited.
Yeah.
Getting closer.
Then we do a Terraform init. Terraform init as we did before. We do a Terraform format check, and that's a good reminder for me to run this locally first, because otherwise my action will fail. What Terraform format does is it makes sure that all of your configuration files are formatted correctly. It's not mandatory, but I think it's a nice way to make sure that you're adhering to some code quality checks. Then we do the plan, and you see here we don't define an out, which isn't mandatory. But we do a Terraform apply with the auto approve, because otherwise, if you do a regular Terraform plan and a regular Terraform apply, the Terraform apply step will actually ask you for a confirmation by hitting yes or hitting the Y key.
Right. Okay.
Which with auto approve isn't necessary.
Yes.
And so with this done, this looks like everything we're doing in the terminal. Where one thing I'll still do just here is run a quick Terraform FMT. And as you can see, what Terraform FMT does is it just it edits your code so that your format is 100% correct. And if you want to see what that changed, we can actually open the file. Can't you see the changes in? Yeah. So what's modified is here I had name equals local.rg name. It added some spaces in there to make it follow coding conventions for Terraform.
Wow. So it wouldn't work without the space, or is it just the formatting that is?
It would
abiding?
work without space. If I wouldn't have this format check in the GitHub action, I wouldn't have to do this.
Oh.
But just to adhere to code quality, I like to, if it's easy for me to do, I'll just do it.
Perfect.
And that's why we're doing this. So I'll commit this again, format it correctly. I'll stage these changes and do yes. And so that's all we have to do. It's all we're doing locally as well. So we can just start our commit and created GitHub action, commit to the master branch. We'll commit this file, and then our workflow should start. So if we go to GitHub actions, we see that our action is already running.
Yeah.
So there's a queued job, and we can then follow along nicely while this is running. I will actually.
This looks very similar to Azure DevOps in the pipelines kind of thing, right?
It is very, very, very similar to Azure DevOps. And the only reason what I'm saying what I'm going to say right now is it's tweeted by the GitHub CEO, but GitHub Actions actually uses some of the same source code as Azure DevOps pipeline.
I like it. So that's Nat Friedman.
Yes,
right?
Nat Friedman. This is nothing internal to Microsoft. This is something he tweeted publicly, and it's just nice to see that those two product teams are working together to make things better.
Yeah.
But we have an error right now, and Christos, you actually alluded to that error because error around building the Azure RM templates. We are not logged in yet.
I stole your thunder there. Right.
Yes, you stole some of my thunder, but that's fine. We need a way to log in to Azure RM.
Right.
The way Terraform now suggests it, or the error message suggests to do this, is by running an AZ login. And we could actually do an AZ login with a service principal in this pipeline.
Okay.
But that wouldn't work nicely with Terraform, because Terraform only uses Azure credentials if it is a user in those credentials.
Right.
If there is a service principal in the credentials, Terraform wants to do the login itself.
Interactively. Oh, wow.
Yep. So we'll need to have variables in this pipeline to allow us to log into Azure. And let me show you what we need to do. Azure Terraform Service Principal. I believe that's the right search term. Yes, so this is what we need. Azure Provider authenticating via a service principal.
Oh, so there's a provider for that. Nice. Okay.
So authenticating to Azure, we're using a service principal. Somewhere on this page is an export. Yep. So configuring the service principal in Terraform, what it needs is it needs some environment variables, ARM client ID, client secret, subscription ID, and tenant ID.
Yep.
So that's how we do this. To get to this, we'll create a new service principal. And if I am not mistaken, the commandlet for this is AZAD-SP84RBAC. And nope, that doesn't have it. Bear with me for a second.
You can always do it in the portal. No judgment. Oh, no, you can do it in the portal. Can you do it in the portal? I think you can, right?
You can do everything in the portal, but I just want to get... the reason I'm using this commandlet is it outputs everything we need in a very easy to consume manner.
Right.
But I just wanted to find how I can give it a name. So I'll give it a name here. So we'll do -- name, and we'll call this, let's say, TF GitHub.
We're not seeing your command line, by the way.
Not seeing my command line?
Nope.
Oh, that's interesting.
We see.
This is just running in.
We still see your creating a service principal using Azure CLI, like in the browser.
Yep.
Okay. Were you seeing my command line before?
Yes.
Yep. But the voice has kind of gone a little a little crackly too. I wonder if it's like just a bandwidth problem at the moment.
Okay.
Maybe transient.
I can. I'll stop sharing and reshare, and then we'll see what this gives.
Okay.
Yep. He lives in the Bay Area. They're supposed to have good internet.
I don't want to sound negative, but the one thing I realized is the U.S. is supposed to be a very developed country, but when you're driving along a highway like Highway 1 and you see an accident occur, there is no cell phone reception to call 911. Ask me how I know. And then there's heat wave in Silicon Valley with all those giant tech companies. And we have rolling blackouts and electricity disappears.
Wow.
And I also noticed that the internet in the US isn't as good. So, yeah.
Yeah,
I don't want to say anything about the US because I actually like living here, but it's, to my understanding, it's less developed than I was assuming it would be.
No, don't worry about that because where my in-laws live, they get their internet is home cellular and it's max 10 megabit. And I was up there for most of the summer, and so of course we were streaming, so I had to go somewhere else entirely. But like their internet would work fine until about 4 p.m. and then it would start to slowly get bad until finally by like 8 or 9 o'clock it would just stop working entirely. And it was awful. So yeah,
I don't have that problem. Quick question: are you seeing my terminal now?
Yes, all good.
Okay, cool. So we'll create this service principal. I hope that there are. What did I do wrong?
Just do Azure AD.
No, I forgot. I didn't have to do --. I think this is the commandlet I need. Yep. So what this commandlet does, the AZAD create for RBAC, is it creates a new service principal, and it by default gives it contributor access to your subscription, as far as I know.
It also creates a password for you, right? Because in the past you could define it, but not anymore.
Yeah. The one thing I will tell you is I hope that you have no bad actors on this Twitch stream, because now everybody could go in and start messing with my stuff. So please remind me when this is done to
wipe out the service principal.
Yes.
Yeah.
So let me quickly paste this in here so I can easily copy paste.
Maybe a self-destruct script for all the service principals.
That could be your next stream, self-destructing service principles.
There you go. All good ideas.
So I was going to go back to GitHub, and sorry, but I'm going to zoom out a little. And in my project, there's settings in my project where I can go in and I can define certain secrets in my project. The secrets can then be referenced by my GitHub action, and the secrets themselves, you only see them when you create them, and your action can then use them when it needs to use them. So I'll create new secrets following bear with me. No, where was I? Yeah, this is the right one. Export. Yeah. So I'll need to create 4 secrets. And home. I'll need to create an ARM client ID secret in GitHub, and the ARM client ID will be the app ID of this service principal.
Yep. App ID or client ID. Sometimes people refer to the same thing with 2 different terms.
It is rather confusing, I'll say. Then the client secrets, which will be this string. That secrets. We'll then need my subscription ID. And that'll be, that's not on here. Let me go into the Azure portal to get my subscription ID. And paste that in as, no, that's only part of it. copy to clipboard, and add subscription ID. And then finally the tenant ID. And that'll be our tenant ID.
Oh, you're running it on your Microsoft tenant. I like it.
Yep. Because Microsoft pays for it. So we now have all those 4 secrets. And then in our GitHub action, we'll create those, or we'll edit our workflow. And I'll actually do this here, because that'll be easier for everybody to follow rather than developing in
Yes,
in a browser.
Inside the browser, yeah.
So we have our terraform.yaml file here.
Uh-oh.
All of this. And it'll show us use those environment variables. And as you can see, it's just either at you can do it at an individual step level, but you can also do it at a job level. So we'll just do env equals whatever. So env.
So those environment variables will be pulled directly from the script, so you don't have to define the value. Is that correct?
So those environment variables will be set by GitHub actions when the action runs.
As long as the names are exactly the same. Is that correct?
Yes. So we need to be consistent, and we need to actually provide these names as the name for the environment variable, and then reference the actual secret. And to reference a secret, is this in this documentation page? No. Creating and storing. Because there's a certain syntax you need to use to access a secret, and this is how you do it. So I will.
Does it matter if it's uppercase, lowercase, or whatever? Are they case sensitive?
They are case sensitive.
Okay, good to know.
I'll do this ARM client ID, and then we need to do the same for the client secret, for the subscription ID, and for the tenant ID.
Are you going to do a multi-line edit?
No.
So close.
Yes. I've done multi-line edits before, but never with dynamic variables. So I'm just going to do what I know quickly.
Yep. Hey, whatever works, no judgment, right?
So this should do the job. And this should allow us to log in to Terraform. So adding secrets, add the change, commit.
Are we missing something because that HashiCorp is underlined there on line 74?
We're not missing something. What this is telling us is this uses containers under the cover to run certain things, and it strongly encourages you to use the SHA hash of the container version.
Gotcha.
That way, you, like on our Terraform file, if something changes, you always go back to the version that you actually want to use.
Got it.
But I believe that this should run. And if not, we'll just browse to error messages and see what's going to happen. And as you see, we went through the plan phase because it errored previously on the plan phase. And now at the
check that out.
Phase.
Check that out. We're applying it. That's exciting.
And we're creating a cluster. Creating a cluster will take about 4 minutes. So let's just let this run. And let's quickly go back to our plan and see where we are and what we still have to do.
Yes. You mean the whiteboard, the original whiteboard, right? Yeah.
Yeah. Where's oh shoot. Give me 1 sec because the whiteboard is at another screen. I need to pull that over. I lost my cursor. Okay, here we are. So this is our original whiteboard.
Mhm.
So we said we are going to create AKS in Terraform, which we
Yes.
successfully did. We then wanted to do a GitHub action to check in Terraform files into Git and then run the GitHub action to deploy the AKS cluster.
Yep.
We did that piece. Next piece is the self-destruct piece. And this requires us to do a number of things. First thing we have to do is we need to create that managed, that AAD pod identity.
Yep.
Which will require us to install a couple of YAML files in our Kubernetes cluster, and it'll also require us to make some changes to the identities that we're using. But I'll walk you through that in a second. But with that, we can actually start. What I propose we do, if you don't mind, is let's use this last cluster that we created.
Okay.
Let's install AAD pod identity manually onto that cluster, see if it works, and just take note of all of the steps we did, and then apply those steps in the Terraform pipeline. Because if we start doing everything in the pipeline, we'll need to spend way too much time waiting for new clusters to create.
Love it. Love it.
Hey, well, let's take a quick break, just restrooms and everything else, and we'll be back in 5 minutes. So
5 minutes.
Right at noon or 9 a.m. or whatever the top of the hour is for you. So we'll be back in just a couple minutes.
Stay tuned, everyone. do it.
Okay. All right, we're back, and we're on to the third phase of our self-destructing AKS cluster. So,
The fun
where are
bit.
we going from here?
Yeah. So, quick recap for those who are just tuning in now. What we've already done is we've created a Terraform file to create an AKS cluster. We then integrated that with a GitHub action where every time we now push a change into Git, we trigger a GitHub action that will deploy everything in the Terraform file onto Azure. And now we will need to make changes to that file to do the self-destruct. And to do the self-destruct, we'll need to do two things. One is we'll need to figure out this green bit right here, this identity piece, this AAD pod identity, and we'll install that first. And then secondly, we'll need to create this cron job in Kubernetes that will go ahead and delete the actual cluster. So let's start with installing AAD pod identity. And to do this, we'll do what I always do, and I'll do a quick
Search.
Bing search for AAD pod identity. This is the GitHub repo for AAD pod identity, and they have a demo on how to deploy all of this. So what I propose we do is we first do this manually on the cluster, so we get an understanding of all the steps. Once we have an understanding of all the steps, we can then go ahead and integrate those steps into our pipeline.
Love it.
So first thing we need to do these manual steps is we need to know which resource group we are in. So if we go to resource groups and delete this and do AKS-SD, we see that the last one we created is 1551, and this one should contain a Contoso AKS cluster. So that's good. Let's use this. And let's do, come on, where are we? Terminal.
That was the output of the GitHub action, or was that something else?
No, that's the output of the GitHub action.
Oh, cool. Okay.
That cluster was created by the GitHub action. And to get access to that cluster, we can do az AKS get credentials with name, I think it was Contoso AKS, and resource group name, the resource group name. And this merges our Contoso AKS context into our kubeconfig file. And if we were to do a kubectl get all, we can see everything that's deployed in our cluster, which is just a Kubernetes service because there's nothing in the cluster just yet.
Very nice.
So we'll start off now by deploying AAD pod identities. We have right now we have a non-RBAC enabled cluster, which is the default if you don't specify it in your Terraform file. So we'll have to create these two deployments in Kubernetes to enable AAD pod identity. And what this will deploy is a deployment. It'll create some custom resource definitions in Kubernetes. I don't want to dive too much into all the details of the things that it creates, but let's just go ahead and create these things. So that's it. So now we created those two things. And if we have a look at our kubectl get all right now, you see that we have a daemon set running, we have a deployment running, and we have those different pods running. And if we were to do a kubectl get crd, and we actually see different objects that are created on Kubernetes. What a CRD is a CRD is a custom resource definition, and a CRD allows you to use the Kubernetes API to deploy, let's say, different objects. And we'll actually use two CRDs. We'll use the Azure Identity CRD and the Azure Identity Binding CRD to create the identities that our pod will use in a second. But first things first, those two things worked. They are deployed. So I'll add them to our workflow file already. After our Terraform apply, I'll add a new step, name deploy AAD pod identity, which will contain a run. And to do a multi-line run in GitHub Actions, you just do run, then the pipe symbol, and then 2 indents later in YAML, you can just paste in the code you want to run, that you want to indent it the right way, because this is YAML. And so this is the command that will run. We can't run it natively like this because our GitHub Actions runner won't have Kubernetes credentials yet. So we need to introduce one additional step here, which is login to Azure and get AKS credentials. Oh, credentials. And this will also need to run a multi-line command. So what I'm going to do now is I'm going to use the Azure CLI, which happily enough is pre-installed on the GitHub Actions runner, which is super nice. So I can just do AZ login, and I think you guys might know this by hand, or by heart, but AZ login service principal. I always forget what the syntax is for this.
You can always do --help and it tells you what to do.
Come on. Here it is. So we need to do AZ login service principal with our app ID, password, and tenant ID. The good thing is we already have those as secrets or as environment variables even. So we could do 2 things here. We could call them as a secret in GitHub, or we can just reference the environment variable that we set earlier. And I'll do it this way because it's a little bit easier to read. So we have the client ID, we have the client secret, and we need the tenant ID. So, and the $sign. So this should work to log us into the Azure CLI. And then the next step would be to do AZ AKS get credentials. And here things get really interesting. I'll do a couple of shortcuts here because I dealt with this in preparation of this. We need 2 things now. For AZ AKS get credentials, we need to have the name of the cluster, which is hard-coded into the Terraform file, which was just Contoso AKS.
Yep.
But we also need the resource group name. And the resource group name was dynamically generated by Terraform.
Yep.
And to get this, let's just say we want to reference this as an environment variable. So we do RG name. But then we need to find a way to assign the output of the Terraform apply to that resource group name. The way to do this in Terraform, let's do Terraform first, is in Terraform, you can declare resources, but you can also declare outputs. And outputs can be whatever you want them to be. So if you were to do a Google search for Terraform output, you can see how you use this. So output with the name of what you want to output and then its value. So if we were to do, just copy paste this and put this in. So one of our outputs will be our resource group name. And the value of that resource group name is simply Azure RM resource group name.rg.name, which will reference here. So that's the name of our resource group name. The way we call this in a shell script afterwards is there's a command in Terraform, and I don't know if they show it. There's Terraform output as one command that you can use, or you can do Terraform output and the actual name of the thing you want to output.
Very nice.
I can't really show this right now in my terminal because I didn't do the Terraform apply from my terminal. So this wouldn't, I don't have an actual resource deployed from my terminal, so you'll have to take my word for it. But I can actually just use this to assign the
RG name to your script.
Yes.
Nice.
One way to do this would be to do just a shell script where I do RG name equals and then do this in shell, and not RG thing, but RG name. That's one way to do this. I've done the preparation, and it's going to be easier if we were to have our GitHub action call back to GitHub and tell GitHub, hey, I actually want you to set a cross-step or a cross-step environment variable.
And nice.
To do this, if you look GitHub actions, set environment variables, there is, I think this is not the documentation page I'm looking for. No, because this is using them. You can actually set them as well.
Is the third result, isn't it? Set environment or something?
No, because that's an action on the marketplace.
Oh, okay.
Maybe it's this one. No, because it is also using. Why did I find this so easily yesterday? Yeah, oh, the previous one was it. Yeah, so here you see you can use the set env command in your workflow to set the same value. So you can actually do a run echo set env name equals your environment variable name and then the value that you want to assign to this.
Right.
So what this would look like in our case is if we go back to our Terraform YAML, I'll actually do this in the Terraform apply step and set environment variables. So I'll make this a multi-line thing. So I'll do my Terraform apply, and then I'll try to set my resource group name, which I tried doing here. So I'll do an echo, set environment, name equals selected color. So my name will be resource group name, and the value will be the output of the Terraform output RG name command.
Nice.
Now, I'm going to tell you the solution to a problem that you haven't seen yet. I
like it.
By default, this does not work because for some reason, the Terraform output command won't show you the output when you call it using this this way of doing things from a GitHub Actions worker. Don't ask me why, but there is a solution for this, and I don't know if I can actually see this in my GitHub itself in my activity. I believe I can, because I replied to an issue yesterday where other people were facing this as well. So I know this is contributions. You can't see GitHub Terraform GitHub action. Let's see. There should be a GitHub repo somewhere, Terraform GitHub Actions. And there is an issue on the right one, because this one was archived. So there is an issue on here that is still open for output, where somebody gave the solution. So Alejo actually provided a solution here, because the only way to do this is to set the Terraform wrapper to false. I didn't really know what this meant. But I found the solution yesterday, which is why I commented on this. So in our setup Terraform command, we'll have to include this with Terraform wrapper equals false, and that'll allow us to actually use the output of the Terraform output command in an environment variable.
This is, I suppose, a hack for now, because technically you shouldn't have to do that, right?
Yes, in my opinion, you shouldn't have to do this, but for some reason it's required. So I'll just add this in here. And just in the interest of time, because we only have until 10 Pacific, if we would have had more time, I would have actually let us hit this error. But for everybody's sake, I'm avoiding the error for now with this thing.
Yep.
So right now, what we have is we have the environment variable resource group name, which is the output of a Terraform output. And we can then call this resource group name in our AZ AKS get credentials and deploy these pods to a cluster. I don't know if this will work perfectly, so I'll just add both files again, our Terraform file because we added that output, and our GitHub Actions file deploying AAD pod identity. I'll already commit this to GitHub, so the action can run in the background while we continue to the next step of our deploying AAD pod identity.
Yep.
So quick recap, we created AAD, we did the first step of deploying AAD pod identity. We have a deployment, which is actually the managed identity controller. And then we have a daemon set, which is actually I think it's the network manager instance or something. What the managed identity controller does is that's the thing that's responsible for making sure that we get the token from AAD. What the NMI thing does is the NMI plays as a network intercept, so that when a pod calls the 169 address to get the token from AAD, so if you go back to the whiteboard, what we showed here, so the VM or the pod will call the token endpoint, which is a 169 address. Yeah. What the pod identity will do is the pod identity will actually intercept that that message, and it'll make sure that it's processed by the controller on Kubernetes rather than a pod automatically calling the endpoint for the virtual machine.
Right. Nice.
So that's step one. Let's now go back to. Did I open that in a different window? Okay, AAD pod identity. So we deployed this. Step two is to create an identity on Azure. The AZ identity create, what this will do is this will create a user-defined managed identity. So that's an identity that you manage and you control.
Yep.
For our manual tutorial that we're doing right now, we'll just follow these steps like we're doing right now.
Yep.
Later on, we will actually integrate this into Terraform as well. But let's copy these steps and open up a quick window here so we can have a look. So we'll do AZ identity create. Resource group name was, I think I'll still have that on my terminal somewhere, or my clipboard somewhere, AKS RG, the 1551. The identity name, we'll just call this AKS as the ID. And we need the subscription ID again. I don't think I still have that on my clipboard. Nope. So let's go to the portal and get my subscription ID. I'll create the identity, and then I'll do a get on. I should have just clicked out the variables. Being lazy is not always helpful. So we'll do this for the group. The identity name was AKS as the ID, so we'll get the name, and then we'll add subscription as well. This is the ID. This will create the identity, and it'll get the client ID of the identity and the resource ID of the identity, because we'll need those two variables in the next step. So if we do this here, there is something wrong. What's wrong? Oh, I think I see it. Yeah, it's on two different lines. So this should be on a single line. So if we do this, this should do the trick. So we're creating the identity. And then we're getting the client ID and the resource ID of the identity. Now that this user-assigned identity is created, we'll also see this appear, maybe not immediately, but in a second, this should appear in our resource group here as well. Maybe if I do a hard refresh. But we now have this identity, and this identity we'll use in the next step to deploy our Azure identities. But let's think about how we will do this in our workflow file in in GitHub. So we still don't see the identity? Oh, here's the identity. So AKS as the ID. This got created, and we will use this to link to our pod. Now, there's two ways we can integrate this into our workflow with Terraform. We could do the easy way out, and for the interest of time, I think I'll actually do the easy way out and create this using an AZ CLI command in our YAML file for GitHub Actions. We could also create a identity using Terraform, and create the identity using Terraform, and then get those IDs also as an output from Terraform. But just for the interest of time, I think this command works, so we can integrate this into our GitHub action as well. So let's copy paste this, go back to our YAML file, and add a new step. The name being create user assigned managed identity, where we will run on a multi-line again. These commandlets. So the group, this thing, we will go ahead and replace this with RG name. This is why I wanted to do this little trick here earlier, because we'll need the resource group name in a couple of steps. So setting this using GitHub, setting this using the set environment so that it's used throughout multiple steps is really easy. So we can use this resource group name, the name of our identity. Let's create a new environment variable here in GitHub, and let's call this ID name, and let's call this just AKS as the ID. I will then look for this thing and replace it with ID name. Need to be careful with the replace, because I don't want to replace this top one, but I want to replace this, this, and this with the ID name. And then last thing is the subscription ID, which we can get. Oh, shoot. Which we can get rid of and call using ARM. Didn't I have a subscription ID in here as well? I thought I did.
I thought you did.
Yeah, here it is, ARM subscription ID.
Okay.
So ARM subscription ID, and replace this as well with the ARM subscription ID. So that should work. Before we commit, let's have a look at what our GitHub action did when we added the resource group name thing. So we can go back to actions, and we see that it had an error. So that's interesting. Let's see, log into Azure and get AKS credentials. Exit code 2. Unrecognized argument. Huh.
Oh, it picked up. Looks like it picked up the. Did it pick up the parenthesis from the end of your command?
So what's happening now is you see this RG name, the $Terraform output resource group name. This should actually be the resource group name.
Right.
So I still did something wrong, and I'll use a cheat code right now and just look at what I did yesterday to make this work. If you don't mind me using a cheat code.
No, it's fine.
No.
I mean, we do it all the time, right? We know that something works. We'll go back to that and we find what's different.
Huh. So set env is the same thing we're doing. Terraform output resource group name.
Is that lowercase though, right? Isn't it? Would that be
yes,
the
but this is because yesterday in my AKS.tf, I think I made it lowercase.
Ah.
So what's different?
You've got quotes around it, right?
Echo double quotes. Let's compare and contrast.
You have single quotes, no double quotes. I don't know if that makes a difference.
That does make a difference. I'll explain the difference in a sec.
It's not JavaScript, folks. It's not JavaScript.
The difference is, and this is a good difference to catch, if you're working on shell, and let's say I say var equals foo. Oh, sorry, var equals foo. If I do an echo with double quotes of $var, it'll actually look at the value of var. So this will echo foo. If I use single quotes instead, this will echo $var. And so what we did wrong initially in our Terraform definition is we used those single quotes. So this call to the Terraform output was inputted as static code. So we need those double quotes. And so here it actually doesn't matter because we're doing a string, but let's just for cleanness purposes do this with double quotes. And let's commit these changes and say changed quotes and added user assigned managed identity. Stage those changes and let's have it run in the background because it takes about 5 minutes for it to create the cluster anyway. So let's refer back to this in a second. But now we have our identity client ID and our identity resource ID, which we need for the next step in the AAD pod identity, which is deploying the Azure identity. And this is created by running this shell script, which I will edit just a tiny little bit. So what this does is this uses an interesting, I like to call it a hack with using kubectl, because typically what you do with Kubernetes is the command kubectl apply -f. What that does is it will look at a file, hence the -f, and it'll deploy what's in that file. So if you refer to what we did earlier, here we did kubectl apply -f, and we referred it to a deployment.yaml file, and Kubernetes will just look at that YAML file and apply that YAML file dynamically on your cluster. The downside with YAML files is that everything in the YAML file is hard-coded. But we're now going to implement this into a pipeline, and we want to have dynamic variables to refer to our identity name, the resource ID, and the client ID. This is the hacky way to solve for this, where what we're doing here is we're using a combination of the cat command with actually having the file on a couple of lines here. It works. It works well. The nice way to solve for this, if I were doing this for a production system, is I wouldn't use this trick with cat. I would actually turn this into a Helm chart, because with Helm charts, if you're not familiar with Helm, Helm is a tool in Kubernetes that allows you to create parameterized YAML files where you can actually dynamically input variable names while you're deploying the YAML file. So that's what we'll do. That's not what we will do, but that's what I would do. Just here, we will change the identity name to ID name because I called it ID name. I will create this AAD pod identity or the Azure identity in our cluster. Let's just see if this runs. Nope. Resource name may not be empty. Did I? Oh, I didn't set the identity name. So ID name equals, I thought we called it AKS-SD-ID. And shouldn't have the $sign in front. So let's run this same command again. And now we have the Azure identity created. Nice. We can integrate this fairly quickly into our YAML file as well. So let's copy paste this, add a new step, which is name create Azure identity in Kubernetes, run, and a multi-line run. Then add this in here. And this is where I have to be honest, my eyes bleed a little looking at this YAML syntax with the end of file with the Azure the end of file indicators, this just looks dirty to me, but it'll do the trick later on. I won't commit this to GitHub immediately because there's an equivalent step. So we created an Azure identity now. Just for everybody who's following, what the Azure identity does is the Azure identity object in your cluster will create a link between your user-assigned managed identity and the cluster that you're running right now. The next thing we'll do is we'll create an Azure identity binding, and this identity binding will allow you to link that identity to certain pods. There's multiple ways to do this. You can do a static binding to certain pods in the Azure identity binding, or you can do this based on a selector. And we will actually do the selector way to do this. And the way this works, and I know I'm going over this fairly quickly, but you'll see it once we're deploying this. The way this selector works is we have our controller for managed identity running in the cluster. And if we use it to look for a selector, it'll look for new pods that get created with a label called AAD pod identity binding identity name. And because we define this here as well, those pods will be able to call the 169 address and get their token from AAD. So this is the final step we'll have to do in our cluster. So let's edit this shell file just a little because we are not using identity name. We are using ID name.
Mm-hmm.
And let's deploy this in our current cluster. This was created, so that works perfectly well. And we can integrate this into our YAML pipeline, create Azure identity binding in Kubernetes. Come on. And then we'll say run, multi-line run this, and make it good YAML, and say created AD pod identity objects in Kubernetes, stage changes commit. Okay, so this will trigger another run of the pipeline.
Perfect.
Let's now have a look at the previous one we were running and go back. And we see change the quotes and added user assigned managed identity. So
very nice.
This works well. And what you will see here, if we do this, you will actually see the environment variables that we're using in GitHub Actions. Let me zoom in. And you'll see here this resource group name, which we created dynamically. This is set in all of the steps. And the same thing will happen once we have that identity that is, oh, this is an error. Huh. I'm very happy we're looking into this because this shows an error. Name expected 1 argument. Still have an issue. Maybe let me try one thing to solve for this because we're setting this in the same step that we're running this. Let's just try name echo identity name run just this single command. Oh, echo name correctly. I'm very happy we were actually looking into these logs because it didn't give a correct exit code, so that's interesting. Okay, let's look into this in a second. But now we have AED pod identity deployed correctly. We can now deploy this this test pod. And what this test pod will do is it'll use the managed identity, and if everything works, it'll say do ARM operation, acquire token, and made a get on the instance metadata service. So this this should do the trick. It won't do the trick just yet for the simple reason that if you remember, we created the identity. we created the identity, but we haven't given the identity a role yet. But we
Okay.
still need to give it a role on a certain scope.
Sure.
And for our purposes, we won't give it the reader role, but we'll give it the contributor role so that it can actually go in and delete certain things. So let's
give me the power.
So we'll actually do a new step. Let's say create a role assignment. Then we'll do run this command. Identity assignment ID. We don't actually need this, but let's just roll with the punches. AZ role assignment create role is contributor. Assignee is identity client ID. We have this. Do we have this variable?
I don't think so yet, because we're not doing a setenv on that, are we?
No, we are not doing a setenv. So we should change this export to we should change this to this, remove this, make this a double colon, and then echo this, remove this quote.
Do you need to put double quotes at the end of the echo? I don't think you have double quotes at the end of the echo.
Yeah, they're here.
Okay. Huh.
And then I'll do the same here. And I'll show you where those quotes come from, because those quotes come from this quote.
Yeah, yeah. I didn't realize we had quotes before. It's fine.
Yeah.
Just
so
trying to make sure we don't miss anything.
So that works. And we'll do the same thing for this identity assignment ID. I don't think we'll use it at any point, but let's just for cleanness purposes. This. Okay, so we do this. So AZ role assignment create contributor. Assignee is our identity client ID, which we have. Scope is subscription ID, and I think we called it something else. We called it.
It was ARM subscription ID, wasn't it?
Yes, ARM subscription ID. Here it is.
Oh, yeah, yep. Right above us.
ARM subscription ID, and then resource groups. And I know this variable because I created it. It was called RG name. Cool. So here we do the role assignment.
Do you need to output a TSV file there? That's the last one, right? The last there just does an output to TSV. Do we need that?
Yes, we need this because we do the -o TSV because we're using this to set the variable.
Oh, interesting. Okay.
So this should do the trick. I will be very lazy now, and I'll go into the portal, and I'll just set this on its own resource group. So I am role assignment. I can just add role assignment. Role is contributor, and we're looking for user assigned managed identity.
I like how you can filter directly to the UAIs.
Yeah.
User assigned identities, because it helps save so much time and effort when it comes to finding them.
And they have a different icon as well, which is nice.
Yes.
So we'll save this. Okay, so it's now a contributor. So this should work. So let's now look into this, where we were going to deploy this deployment and validation. If I am not mistaken, I believe this should work. We have all those variables, although resource group name needs to be RG name.
Yep.
And identity name needs to be ID name. So let's go back to our thing here. Let's quickly change this to YAML. So identity name needs to be ID name, and resource group needs to be RG name. And I don't think I have a variable set in my shell for subscription ID.
No, we've been.
Yeah. So subscription ID equals. Do I still have it on my clipboard?
I don't think you ever put it on the clipboard for some weird reason.
Okay, let's go get it again. Overview. Copy. Paste. Now we have that. And then identity client ID, do we have this? Yes, cool. We have this. So let's run this. Let's see what this does. So, okay, this created a demo pod. And then we can do kubectl logs demo -f. Pod/w. Well, the error we're seeing here is that the container is still creating, so it's just telling me be patient. What's happening in the background now is just the Kubernetes node is pulling in the Docker image and then actually creating the container, which is now running. So now we'll be able to get the logs. So it started the pod, which is good, but it's not doing anything else. What I started doing yesterday as well, and do is the controllers here also have logs. So if we do kubectl logs of this guy, this still gives me an error.
There it is.
Yeah, I remember this from yesterday. The client 0626 with object ID 0626 does not have authorization to perform action virtual machine skill sets write over our skill set. So this client ID, I won't bore you with all the details, but if we go to our managed resource group that was created for us, we were in the 1551.
Mm-hmm.
If we go in here and we go to our VMSS, this guy has a system assigned managed identity. So if we go to identity here, this also user assigned. Oh yeah, this has also a user assigned managed identity, Contoso AKS agent pool. And you'll see that this object ID, this 0626, is the one that it's complaining about.
Yeah,
0626.
it matches.
This identity, Contoso AKS agent pool, doesn't have rights to make changes to the virtual machine skill set in our managed Kubernetes cluster. So if we go into our managed Kubernetes cluster and we look at IAM, you'll see that this, what was this again? Contoso AKS something. The agent pool, this one right here, only has reader access to my cluster, where it actually needs contributor access.
Yep.
So we'll, come on,
So
let's copy paste this.
So why is
Go ahead.
that? Why is that identity being used compared to the identity that we created?
Okay, that's a really good question. And the reason that identity is being used is because if you think about this this setup, we are creating a managed identity for our pods.
Right.
Now our VM needs to. Don't think I can draw without. No, sorry, I won't be able to draw, or I have to move this over to my Surface again. That VM needs to use an identity to make changes to the cluster as well, and you don't want to give the identity that makes changes to the cluster also to the pod. So there's two different identities that are in use here.
Okay.
One identity to make changes to the cluster, and then the other one just for the pods that'll actually use an identity to log into Azure.
Right. So which one is
the big question?
Which one is your pod trying to use currently?
So my pod that is going to do curl is not this identity, because this is the identity of the agent pool. My identity is the one in this 51 cluster, which is the AKS SD ID. So this one is the one that we'll use to delete the cluster. Or actually, we won't delete the cluster, we'll delete the resource group of the cluster later on. But we will need to provide access credentials for this guy. So for this agent pool credentials, we'll need to give that access rights on our contributor rights on our managed resource group.
On the managed resource group, not on the actual resource, not on the node resource group.
No.
Okay.
So to do this, we'll do the same thing as we did earlier. Create role assignment and create role assignment for, let's say, pod identity. We'll need to do the same, create a role assignment, but for the cluster identity. And to do this, we'll first need to get the cluster identity client ID. Fudge. I'll just call this cluster client ID. And this will be not in the resource group, but it'll be in the managed resource group. And this will follow a certain naming convention that I'll just quickly steal from yesterday. Where were we? We were here. So our managed cluster will also always follow a naming convention, which will be MC for managed cluster, the resource group name, and then the cluster name, which in our case is not AKS SD, but I think it's Contoso AKS. If I'm not mistaken, in WestUS2, the identity name is something that will always be the same, which was Contoso AKS. I think it was agent pool. I had it on my clipboard. Contoso AKS agent pool, so that's good. And it's in the same subscription, so this should do the trick. If we run this in my terminal, then to show subscription. Oh yeah, we use subscription ID here. What?
Do you need to remove the dollar?
No, or I think I set the subscription ID here. Yeah, it was in a different terminal. I'm sorry. So let's just paste this command in here. And again, ARM subscription ID needs to be subscription ID. Sorry about that.
Ooh. Oh, you don't have the.
Yeah.
You don't have the RG name.
And the RG name was the thing with 51. So AKS 51. Go up. Come on. Echo this thing. Huh.
You have a dollar in front of the RG name, is that correct?
Yes, that's correct. But I think if I do this differently, remove those double quotes. No.
Huh.
Why the hell are you not doing what I want you to do? Let me do something else. Just do cluster ID. This, because I was actually using the GitHub thingy. We'll need to change it in a second as well. Let's see.
It seems I can't find the RG name for some reason.
Yeah. So I'm doing something wrong. Huh.
Do you need a dollar in front and the back of the RG name? No.
No. This is what I do.
Holy moly.
Yes. So let's change it in the GitHub thing as well, where we'll do. How will we do this?
Well, first you need to run the echo command, right? The full thing, or you don't need to do that anymore.
Let's see. Let's see if I go into here, and if I change this MC thingy with the magic of all the double quotes, let's see what happens.
There you go.
That works. I want to check this as well in the echo command, because in the echo command, we're doing the same thing. because the echo command is actually what will run on the GitHub action.
Yep.
Okay, cluster client ID equals this client ID, so that's good. So
Okay.
this is what we need in our action. Although before I do this, let me paste this in and replace subscription ID with ARM subscription ID. So let's do the same trick as before, where I'll call this echo identity name, echo cluster identity name. That was the assignment. And so we'll need to do this again. Role assignment for cluster identity. And we'll do assignment ID equals role assignment create contributor assignee, not client ID, but I think I called it cluster client ID. In scope subscription, ARM subscription ID, and the resource group name needs to be that weird little thing we did before. Okay. Let's see. If I run this in my terminal, what will happen?
Resource groups. Is that an S by mistake? An extra S by mistake?
No, it's this ARM subscription ID.
Ah.
Looks like it's going through.
Yeah. We're staying here with anticipation, see what happens.
Yes, I have an inkling feeling that we won't be able to finish everything in 9 minutes.
No pressure. Just 9 minutes.
No. Okay, so this this works. So we now have all the role assignments. I'm going to add one thing just for certainty because I ran into a similar issue yesterday.
Yep.
I am going to give this role assignment as well to the regular resource group. I don't 100% for certain know if we'll need it, but yesterday I think I did when I was preparing for this. So just to avoid any more errors, let's do this as well. The reason I think we need this is from what I figured, when we do the AAD pod, when we create the AAD pod identity, it also does a write on the managed identity of the pod for some reason. So with all of this done, let me quickly go back to kubectl get pods. Let's kubectl delete pod demo, just to have a clean slate to begin with. And then let's recreate this demo pod. We don't have to change anything here. So this is now deleted. Let's try this again. kubectl get pods. Okay, kubectl logs demo -f. The pod is started, but nothing good is happening yet. Logs, this guy. Creating assigned ID. Okay, so no more errors. So this is now telling us that it needs to delete one because this is when we deleted the identity. And now it says we need to add an identity. So it needs to add one, and it's updating user assigned identity on AKS VMSS. So this is working. Found one pod. So this is all looking good. So with a yep. So what you see here is our demo pod was actually able to do a get on the instance metadata service, which is what we wanted to achieve.
Nice.
So
Nice.
This is pod identity working on our demo cluster. And then with a little bit of luck, if everything in our Terraform file works correctly, and this should set up AAD pod identity correctly, but we need to check that it works fine. So let's commit these changes. And let's have a look at the last pipeline we ran in GitHub Actions. So echo name correctly, that worked. So this one, the last one we did, create identity binding. If we have a look, this actually created the identity binding in the latest cluster we created. So that's good. The only thing we didn't do there was the role assignments, but the role assignments are done now. So all of this looks pretty good, to be honest. So if you go back to the whiteboards, we now have the pod identity configured the right way. The only thing that we still have to do is to trigger the cron job to actually go ahead and, once a cluster is created, go ahead, spin up a pod and delete the resource group.
Yes.
So that's the last thing we have to do. So let's say the last step here is add auto delete, which will also be a run over multiple lines. And do we want to build this, or do we just want to use the cheat code and explain what I built yesterday?
Well, considering that we only have 5 minutes, you might want to do the quick.
Yeah.
Unless you can do it in 5 minutes. I mean, that's a challenge.
Could you slide your sidebar over a little bit? There we go. Perfect.
Yeah.
Perfect.
I'll copy paste what I did yesterday, and I'll add this in a new window first. And it detected that it's YAML. So what we're doing is we're adding the delete job here, doing the same kubectl apply job with cat. We're creating a cron job. The AAD pod identity will not be delete identity, but we'll call this ID name. The schedule, this is just a cron schedule. Star divided by 1 means every minute run this job. We'll do the same thing where we replace the delete identity with $ID name. And then we're starting a container from a Python 3.7 Alpine image. We're installing curl in that image. We're echoing curl is installed. We then query the managed identity endpoint, that 169 address, to get the token back. We then get the actual token, because the HTTP response contains more than the actual token. And we're just processing this using Python and getting the access token. And once we then have the access token, we'll call curl delete using the access token on $RG name, which is what we'll do.
Nice.
So maybe I'll change one thing here, because this still contains my hard-coded subscription ID, ARM subscription _ID. So this should do it. I don't think we'll be able to show this quickly in our pipeline, but let's copy this into our pipeline. And it's a little prettier. Added delete command. Add these changes and commit. But one thing we'll be able to do is, since we have a cluster right now, we are able to run this on our current cluster. So let's do a copy command of this, put it into our terminal, and let's see what happens. This won't work, sorry, because let me just make it work. Let's say ARM subscription ID equals, ARM subscription ID equals $subscription ID echo ARM subscription ID. Good. So now this will work, or should work. So let's.
I like the confidence.
Let's do this cat trick. Let's make this work. The cron job is created.
Damn, nice.
A kubectl get cron job will see the cron job, and it actually was scheduled 5 seconds ago. So we were lucky that we were just at the minute change. So if we now do a kubectl get pods, we see that our hello thing actually completed. So if you do kubectl logs of this guy, it says that the delete was executed.
Nice.
So now
At the
15.
nick of time.
So is that 1551 should be gone?
It should be deleting. So if you
Deleting,
go
yeah.
into the activity log of this one, with a little bit of luck, it takes a while for delete commands to show up, but with a little bit of luck,
You might see it before 10 o'clock. That would be impressive.
yes. I think I've got 30 minutes to go over because I think my next meeting is at 10:30. So if you don't mind, we can go over like 5 minutes.
Sure.
Yep.
Come on, this delete should show up. Come on, demo gods, be kind to me.
So when you delete the resource group that your cluster resources are in, what happens to the parent, or to the, not the parent, but what happens to the managed resource group?
The managed resource group gets deleted as well, because what happens when you delete a resource group, what happens in the background is when you delete the resource group, all the resources in the resource group get deleted. And I see that one resource is already deleted, so I think it actually worked. And then the AKS cluster will be deleted as well. And once this is deleted, it'll delete the managed resource group automatically for us.
Okay.
So if we check the activity log, come on. There's always some time delay to get actions into the activity log, so that might be why. But you actually see that delete user assigned managed identity got triggered by this C00 FD8 thing, which I believe is the
identity ID.
Was the user assigned managed identity.
Mm-hmm.
So if I were to do echo, I think it was client, no, identity client ID. No, that's another ID. Sorry, but the one thing I can see is that everything is getting deleted right now. So in our manual cluster, this worked, which is good. Let's now have a look into our GitHub Actions pipeline. And so all our identity checks worked. So this is super awesome. Even if I say so myself.
Super awesome indeed. We can concur.
So it's creating all the role assignments for us. It said something about insufficient permissions, so it's not working. Yeah, I know the issue. We can try to fix it, but we'll have to wait another 5 minutes. To show you what the issue is, we're at some place we're doing a role assignment, create a role assignment for the pod identity.
Yeah.
The issue is the identity that's doing this
does not have the right permissions.
Nope.
It needs to have is it the account management permissions?
Yes.
RBAC? Yeah. See.
So we could go in here and add a role assignment to, I think it was, what did I call that? So
because contributor alone does not allow you to assign permissions to other users. You need to have a specific RBAC permission, which is either account administrator or owner.
Yes, I think it's user access something, user access administrator. Yes. Lets you manage user access. I'll just give owner just to be sure. And
why not?
I called my TFGH action SD. So if I do this, adding the role assignment as owner to my subscription, and I then go into GitHub Actions and I rerun these jobs with a little bit of luck from the demo gods, and let's all pray together. This should do the trick. Before we do a wrap up, let's have a quick look at that 1551 cluster. And this resource group is still around. Let's have a look at the activity log. Now the delete event should be in there. And I'm only seeing the delete user assigned managed identity, which is strange.
Is it hanging?
So I'm not entirely certain what's happening here, but I think just in the interest of time, I don't know how you guys typically end, but do you want to do a quick recap, and then at the end of the recap, we can check if things are working correctly?
Sure.
Yeah.
So what we did is we created, we created an AKS cluster in Terraform, which worked pretty well from the get-go. We then integrated that with a GitHub action, where every time we commit in Git, we trigger a GitHub action that deploys our AKS cluster, and that worked pretty well. And we then started integrating the AAD pod identity. We spent a little bit of time on trying to figure all of that out. I believe we got it working in the end, but let's verify this in a second. But as you saw, there's a couple of steps that you need to do to set up this AAD pod identity, and you need to make the right user assignments. But with the identity in place, we then were able to create a Scrum job, and the Scrum job was triggered on a every minute schedule. So every minute, the Scrum job creates a job object, which will then go against the Azure API and try to delete the cluster. With a little bit of luck, and maybe the repo is open source, so everybody should be able to follow along with what's happening there. If it doesn't work, I'll make some changes to make it work. And I hope this was useful for you, and I hope this was a good 3 hours for you to spend on this Twitch stream.
That was great.
It was great. We learned so many things.
I'm putting a link to the GitHub repo in here. No, this was awesome. Like, it's just sort of amazing how many moving pieces there are. But no, I think it's really fascinating, and to be able to do this over and over and over again without with one set of secrets for GitHub, right? The GitHub actions, that's really the only manual secret that we had to create. The rest of them are all managed, so we don't have to do them on our own.
Yep.
No, this is super awesome. No, I think this was great. Thank you so much for spending your whole morning with us.
Morning. Yeah.
Oh no, this is fine. This was super fun for me. I told Christos, I think before we started, that this is my first time doing a live stream while building something, and it's a lot of fun. You might have gotten me hooked.
Oh, look at that. We have a convert.
Yeah, you're welcome back anytime for sure. So
absolutely.
Just when you start running your own show, just don't do it at 7 a.m. on Tuesdays. We don't want to have to compete, So, no, this was awesome, and let's see. So Tuesday we will be back, this coming Thursday. 2 days from now, we'll be back at 11 a.m. Eastern, 8 a.m. Pacific, and we're gonna have some community news and views. And anything else going on Thursday that we know of yet? Is there anything we need to announce for Thursday? I don't think so.
Nothing yet, but we're gonna have probably a surprise guest.
It'll be a surprise to all of us Thursday morning.
Surprise for us as well.
And then I think we're gonna get back to building. We're gonna go back to building some. I think we're gonna build some React, build more on our React MSAL JavaScript stuff to wrap that in a token credential sometime in the next couple of weeks. I mean, we got a whole list of stuff, but if there's anything you want to see us do, find us on Twitter. Find us on. You can send us an email. We've published that before, and feel free to go check out Nills' repository of all the great work that he did with us today, and follow him on Twitter and on GitHub and everywhere else, and soon Twitch, it seems. So, Nills, thanks again. This is awesome, and it looks like the job's all succeeded.
No, it said again insufficient privileges to complete the operation. So I'll have a look later today, and I'll finish everything up, and I'll tweet to the both of you that everything's fixed, and I hope I can fix all of this today still.
All right, awesome. Perfect. Well, just let us know. We'll be around.
Don't go, everyone, because we're going to raid Visual Studio now, right?
Is it Visual? Is that all we got today?
Yeah, we'll have Visual Studio from what I can see.
Oh, tomorrow at 10 a.m.
Oh, yes.
I can't believe we almost forgot the missions. Tomorrow at 10 a.m. 10 a.m. Pacific, right?
Correct.
our friend InstaFluff is going to be streaming about Azure AD B2C, and we'll be there in the beginning just to say hello and sort of let everybody know what's going on. So make sure tomorrow you go over and check out InstaFluff at 10 a.m. Pacific, 1 p.m. Eastern. I'll put a link down here. Go follow him today, so you'll get that. Go follow him today, so you'll get that
notification when he goes live.
Notification tomorrow morning.
Yeah. See you tomorrow at 10 a.m.
And I guess we're gonna go. I guess we'll go over to Visual Studio. I don't really see anybody else online. So, all right, we're gonna. I guess we'll head over to Visual Studio.
Thanks everyone for sticking around.
Thanks everybody. Thanks Nills.
Cool.
See everybody. See you in 2 mornings. Have a great rest of your day.